The UPSC CSE arena is an ever-evolving space where staying up to date becomes as crucial as maintaining a thorough preparation. With strategic planning and holistic coverage for exam syllabus, Vision IS Delhi presents GS Foundation course. Avail analysis and integration of current affairs with GS syllabus. All India test series with an innovative assessment system, inculcating post-test analysis, discussion, all India ranking, and more. Explore the holistic learning modules intrinsically designed for the ideal aspirant.
Hello, good afternoon, everyone. We are going to discuss hopefully in these two classes, we are going to complete the questions of science and technology asked by UPSC in last 10 years. So from 2015 to 2024. And there is a very nice PDF prepared by the team. "10 years UPSC PYQ trend analysis for science and tech." It's a very nice PDF. You get a lot of information about. So I'm very sure that you can find this PDF somewhere on the website, and it should definitely be available on the YouTube video when it will be uploaded. So in the video description, the link to this PDF definitely will be there. So I highly recommend that you can download this PDF, and you'll get a lot of idea about the number of questions, about the sources we should refer to. Right, of course, questions and detailed explanations, all of those things you can find at one place. Since I already have my own PPT of previous year questions, so I'm going to use my own PPT, and that also will be available in the video description on YouTube. Right, so I'm going to show you PPT of previous year questions topic wise. I have my own way to categorize questions, so I rely upon that categorization, and I recommend that you can download this PPT also. So this is what I'm going to do. In science tech, few things I'm very sure that all of you already know, that for prelims, because the syllabus is not fixed, the word is simply mentioned, there is general science, which essentially mean that they can ask questions from any topic if they want. And they have asked questions from any topic. And you'll see that at least in basic science questions, there is a huge variation in the nature of question and difficulty of question. But the technology part, which is the major focus of UPSC, like about 80% of the questions will be from technology part only. So technology part questions, they are more simpler. They are simpler and application-based questions, and even a very basic understanding of topics that helps you a lot in answering questions. So in any case, even though the syllabus is not defined per se, if I look at the previous year questions, then I can fit them into either of these categories. There will be questions of basic science, and also I've included one more thing here, advancements in science, not access technology, but advancements in scientific understanding about nature. A lot of experiments are happening all across the world. So I have put that topic also here in the basic science itself. right? This is, you can expect 1 or 2 questions from this topic almost every year on basic science. Then biotechnology and health together are very important topic for prelims. They're important for mains also, but for prelims they are very important. Space technology and developments in astronomy, that is another very favorite topic of UPSC for both prelims and mains. For prelims, this may be the most favorite topic of UPSC, the advancements in ICT. But ICT is a huge domain. So uh, I am including many things in ICT. I am including all advancements in communication, in computing, in electronic devices also. So I have included everything in this discussion about information and communication technology. So if for prelims perspective, these 3 topics carry the maximum weightage from the technology section. If I remove the basic science part and only include the technology section, then biotechnology, health, space technology, and information and communication technology, they have the maximum weightage of the questions. There is a domain, nuclear technology, which is from time to time you expect a question on nuclear technology also. जैसे इस साल 2024 में question था, last year भी there was a question. Defense technology has become I would not say surprising, but defense technology has become important in these last few years. Like almost every year UPSC is asking a question on defense these days. And most of the questions, goes without saying, across all the topics are inspired from current affairs. Another very favorite topic of UPSC in last few years, which has emerged, is advancements in material science. And I often say this in my classroom, that material science is this unsung branch of technology, that we do not think a lot about material science. We think about advancements in space or healthcare or artificial intelligence, but we do not think a lot about material science. But without material science, all of these technologies will simply not be possible. That when you make a rocket, then it has to be thermal resistant material. When you make a medical device which needs to be inserted inside body, it should not be toxic. When you make a mobile phone, the display part should be scratch proof. And then the electronics inside the mobile phone which you cannot see, what material should I use there? So material science has applications across all domains of technology. And the advancements in material science, particularly some interesting materials which scientists are discovering, making in lab and finding unique application. This has also emerged as a favorite topic of UPSC. And it goes without saying that one of the reason in the advancement in material science has occurred is this advancement in nanotechnology. So I've included these 2 things together here. IPR is given in mains, and I found a question in prelims examination also on intellectual property, right? So I don't know where to put it, so that is why I have kept it. But you can ignore this topic for prelims particularly, you can ignore. And even if there is a question on IPR in prelims, I would rather consider this as a topic of polity and governance, where you are supposed to know about some important laws, like patent laws में कुछ change हुआ है, copyright law में कुछ change हुआ है. So I would think of this as a topic of polity and governance. Energy, I have included it here. So apart from nuclear technology का एक जो बहुत important part है, वो nuclear energy है. But apart from nuclear technology, the other advancements in energy production, which includes renewable energy or hydrogen-based energy, so that can also be added here. But since I also teach this topic in environment classes, so I'm not going to discuss the topics of 1 or 2 topics जहाँ पे technology पे ज़्यादा focus है. We will be talking about that. But you'll find that UPSC is asking many questions from this domain. Another domain of technology which has become very favorite of UPSC is technological solutions to fight environmental problems or social problems also. So again, these are things which you study in environment. So I have not included here in science and tech question. जैसे इस साल मेंस का ही question देख लो आप, water shortage and technological solution to tackle water shortage. Right? So it's a serious social problem. And how can technology help us in finding solution to water shortage? Or think of some questions in prelims examination this year. There was a question on membrane bioreactor. That is a technology which helps in water purification. Right? Or there was a question on फ्यूल सेल का एंड बाई प्रोडक्ट क्या है, और देयर वाज अ क्वेश्चन ऑन पम्प्ड स्टोरेज जो है वो क्या है, देयर वाज अ क्वेश्चन ऑन डिस्ट्रीब्यूटेड एनर्जी जो है वो क्या है, लाइक विच ऑफ द फॉलोइंग आर एग्जांपल्स ऑफ डिस्ट्रीब्यूटेड एनर्जी. सो यू फाइंड दैट दिस फोकस ऑन advancements in energy production, energy storage, the focus on environmental technologies, like technological solution to fight environmental problems or social problem. This is another very important theme for both prelims and mains examination. But I have not included these topics here in science and technology class. I think that will be separately discussed in environment class if it already has not been. So let's start the discussion, like without spending more time into it. Let's start the discussion. For the past few year questions, I have a more detailed analysis in terms of, I also have linked to the newspaper articles and headlines where you can see that where a theme of the question was picked, or hopefully in fact maybe the entire question was picked, but definitely theme was picked. I do not have the same level of analysis for questions of 2015, 16, 17, right? But nonetheless, we will discuss about the basic concepts of almost each and every question. And if you have any questions, by the way, feel free to ask questions whenever you want. That's not a bar. So anyways, let's start the discussion with the first set of topic, basic sciences. Before that, one more thing, two more things. साइंस एंड टेक का जो बेसिक साइंस के लिए आप जितना आपने एनसीईआरटी में पढ़ा है, एंड उसके अलावा कुछ भी अगर इंटरेस्टिंग बेसिक साइंस में अगर हो भी रहा है, द न्यूज़ पेपर्स ऑल्सो कवर इट. यू आर नॉट सपोज टू रीड द ग्रेजुएशन एंड 11th 12th टेक्स्ट बुक ऑफ फिजिक्स एंड केमिस्ट्री एंड ग्रेजुएशन टेक्स्ट बुक फॉर दैट, right? So whatever is given in newspaper about some advancement in science, not technology, then that is more than enough for prelims or mains examination. So that is why, except 9th and 10th NCERT, I do not recommend any textbook, standard textbook to do this topic, because most of the questions will be doable by the Hindu or Indian Express. This website has been now like disbanded, indiascience.in. And of course you should ideally also complement your primary newspaper reading with some monthly magazine. You can choose any one you like, but Vision IS does have a very good coverage, so you can choose that. But it should be very clear that this monthly magazine is a complementary material. It should not be your primary source of reading. Right? Whenever you do come across a news in monthly magazine, then it should not be a new thing for you. Like, you should be able to remember that, yes, I read that just a month ago. Right? And that is the ideal way of preparation. So for me, these two are the most important sources. Ideally, one newspaper in entirety and the other newspaper जो explained and editorial section है, at least that part should be done. ठीक है? So this is, and it should take time. It should take about 1.5 to 2 hours. If that is your doubt that newspaper में बहुत time लगता है, लगना चाहिए. Right? And so all serious good candidates will take newspaper reading seriously. It helps you in multiple ways. It's not just about preparing current affairs. It's also about writing skills, about transitioning from one thought to another thought. So ये याद रखना है कि prelims खाली आप qualify करते हो, but final selection तो mains में आता है ना. So you have to write answers, you have to write an essay. तो आपका prelims जो है end नहीं है, end जो है final selection है. So newspaper reading is going to help you in that part, in answer writing part and in essay writing part, and overall in making you a better candidate, a well-read candidate, a curious candidate, right? So that is why there is no substitute to newspaper reading. Anyways, and one more thing before I start the discussion, that if I have to talk about the nature of questions asked by UPSC from science and tech, then most of the questions are current affairs inspired. And even though compared to other topics, science and tech prima facie may seem like a more difficult topic, but it is also a more attemptable topic. So if let's say there are 10 questions or 12 questions in prelims examination, then you should attempt 90% of the questions from science and tech, and you should also get 90% accuracy. So if there are 10 questions, then you are attempting 9 and you are getting 8 correct. That should be your goal. And it is very much a doable, achievable goal, irrespective of your educational background. Because a lot of students are fearful of this subject that I haven't studied science after class 10th and 12th, and it doesn't matter. You just have to put into more effort, right? That's it. You have to put into more effort. But ऐसा कुछ भी aptitude नहीं चाहिए जिसके लिए आपको ग्रेजुएशन में अगर आपने साइंस इंजीनियरिंग मेडिसिन नहीं किया तो आपको समझ नहीं आएगा. ऐसा कुछ भी एप्टीट्यूड नहीं चाहिए. जो जितना चाहिए वो न्यूज़पेपर से हो जाएगा, आप समझ सकते हो. मैथ्स का कहीं पे कोई ज़रूरत नहीं है. डू नॉट हैव टू डू एनी मैथ्स एनीवेयर in this entire discussion. If you have a basic understanding of topic, you can get most of the answers correct. And this is definitely true for technology questions. For science wale jo question hai, there may be challenge in some questions, not in all. Even in science questions, you will find that many questions are actually quite simple, quite straightforward. But in some questions, that can be a challenge. And I will, because I'm going to start with the basic science part, so let's do away with this some of the difficult question in the starting of the discussion itself. That is my first topic, that we will look at the topics of basic sciences asked by UPSC, and also some of the most advanced scientific experiments which are happening across the world. Okay, so there is a question on, this is a current affairs inspired question. The term end arc, sometimes seen in the news, is the name of, this is, if you know it, you know it. If you do not know it, then do not need to take any guesswork here, right? So ये बहुत simple है, that this is an underwater observatory to scientifically study the Arctic region, right? So when you look at the responsibility of ministries in India, which have bearing on scientific and technological development, then 3 ministries clearly stand out. Apart from that, 2 more departments which directly come under Prime Minister clearly stand out. So you have Department of Space and Department of Atomic Energy directly working under Prime Minister. They do not work under any ministry. But apart from that, there are 3 ministries. The first is Ministry of Science and Technology. And Ministry of Science and Technology has 2 very important departments: Department of Science and Technology and Department of Biotechnology. And then you have the second ministry is Ministry of Electronics and Information Technology, which again has many departments. Department of Telecommunication or Department of Electronics is the most important department here. And then you have Ministry of Earth Sciences. So Ministry of Earth Sciences is also very important. And in few domains, in 3 domains, they have the primary responsibility. The first is वेदर फोरकास्टिंग एंड क्लाइमेट मॉडलिंग. तो जो भी वेदर फोरकास्ट होता है जो आप देखते हो, जैसे IMD जो है, इंडियन मेट्रोलॉजिकल डिपार्टमेंट, दैट वर्क्स अंडर मिनिस्ट्री ऑफ अर्थ साइंसेज. एंड देन ओशनोग्राफिक स्टडीज, जो भी ओशन साइंसेज में स्टडी हो रहा है अबाउट वेव पैटर्न्स एंड ओशन करेंट्स और इंक्रीज इन सी सरफेस टेम्परेचर, ऑल ऑफ दैट विल बी again done by Ministry of Earth Sciences. And third is polar research, all type of polar research. So our research stations at Antarctica, such as Bharti and Matri, and our research station at Arctic, such as Himantri, and INDARC. So INDARC is not a research station. INDARC is more of many instruments which we have placed underwater. The goal here is to understand about Arctic sea ice in more detail. So it's not like Bharti or Matri or Himadri, which are research stations where Indian scientists are working there and overall trying to understand about knowledge of poles and how poles affect the Earth's climate system. So INDARC is more of many instruments placed underwater, trying to understand about the salinity of sea ice, melting of sea ice, the impact of sea ice on overall Earth climate. Right, so this is what INDARC is, not as such a research station, but an underwater observatory to scientifically study Arctic region. So, इसका आंसर जो है D है, and it should only be answered if you know about this. If you do not know about this, then maybe I think that it can be a challenging question. The next question is, I specifically remember why this question was asked by UPSC. In the context of modern scientific research, consider the following statements about Ice Cube, a particle detector located at South Pole, which was recently in the news. Why this question was asked? Because around the same time, Government of India had proposed that we are going to make Indian Neutrino Observatory in Tamil Nadu. And there was a lot of protest against this. In fact, some protest is even there by Tamil Nadu government. At that point of time, the protest had कोई बिना सर पैर का protest था. That जो artificial neutrino है, it is dangerous. It has very dangerous radiation, can cause diseases. All of those things were there, which are simply not true, right? So there was a lot of protest against this construction of Indian Neutrino Observatory. And then newspaper articles covered some of the most important neutrino observatories of the world. And the biggest and the largest neutrino observatory is IceCube. And that was also covered in newspaper. And then UPSC picked this theme and made a 3-statement question on it, okay? It is the world's largest neutrino detector encompassing a cubic kilometer of ice. It is a powerful telescope to search for dark matter. It is buried deep in the ice. यहाँ पे second statement थोड़ा सा problematic इस sense में है that I should not use the word telescope because the meaning of the word telescope is very precise. Telescope is more about gathering light. भले कोई भी light हो. It can be visible light, ultraviolet light, radio wave also. But nonetheless, this part is true that it aims to search for dark matter. And UPSC did consider that second statement to be correct. And third is again correct, it is buried deep in the ice. And uska ek simple sa karan ye hai. So let me show you what this IceCube observatory looks like. If you go to Antarctica, Antarctica is really huge. But at one place in Antarctica, on the surface you will find this research lab. But the actual scientific instruments are up to 2.5 kilometer deep inside ice. So on the surface, the part which you saw, that is the part. But the actual instrument is actually, all of these instruments are placed quite deep inside this ice. And the reason is simple. Neutrinos are mysterious particles. Neutrinos are the second most abundant particles. They do not have charge. Since they do not have charge, they are not affected by electromagnetic force. They have almost zero mass. I will not say that they have zero mass, but they have almost zero mass and they travel with very high speed. They're also not affected by strong interaction, another fundamental force which exists in nature. So they're only affected by two interactions. First is gravity, everything is affected by gravity. And second is weak interaction. There is a fundamental interaction called weak interaction. The best example of release of neutrino in a nuclear reaction is reaction called beta decay, which you have learnt in your radioactivity classes. That certain nuclei, when they are not very stable, then they disintegrate into lighter nuclei. Not disintegrate, decay into lighter nuclei. Think of carbon-14. Carbon-14 is a radioactive isotope. It emits beta particle, which is electron, but it also emits neutrino. Right. So this is a very good example of one of the way, in fact, it releases anti-neutrino, but doesn't matter. It's a very good example of a reaction which is producing neutrino. But the most prevalent reaction which produces neutrino is nuclear fusion reaction. That in the core of star, when hydrogen nuclei fuse together and form helium, they also produce neutrino. So stars are the biggest source of neutrino. So stars release a lot of light. Light is made of photon. So photon is the most abundant particle. But the second most abundant particle in the universe is neutrino. And since neutrino is not affected by charge, is not affected by strong interaction, every second, all of us are being crossed by billions of neutrinos. And we are not affected by it, and those neutrinos are not affected by it. And most of these neutrinos were produced in the core of stars across the universe. And these neutrinos can travel lights of years without being affected. They can cross entire Earth without being affected. And that is why all of the neutrino detectors you will find that either they are deep into water, they are deep in the ground, in this case deep in the ice. Because most of the particles, these microscopic particles, electrons, protons, alpha particles, neutrons, all of these particles will be filtered out by different layers, but neutrinos will not be able to filter out. So these setup are often located underground, because now whatever we are detecting neutrinos. So that is third part. We can appreciate this, that it is buried deep in the ice. And even today, the first part is correct. Even today, although this question was asked in 2015, but this first part is correct even today, that it is actually world's largest neutrino detector. Okay, why second is correct? Dark matter is a concept. Dark matter, and I will repeat, it is only a concept. We actually do not know if it is real or not. Science progresses by developing some hypothesis, that there is some experimental data you have come across. You're trying to explain that data and you develop a theory about it. And then this theory can be proven wrong and can be proven right by more subsequent experiments, right? And I often give these examples of the discovery of Neptune and the problem with Mercury. When scientists in 20th century, with help of powerful telescopes, looked at all the planets, they found that the orbit of Uranus is not exactly what Newton's law is predicting. Remember, with help of gravitational law, we can explain orbit of all the planets. But the orbit of Neptune was not exactly what Newton's law is saying. There are two possible explanations. Either Newton is wrong, or there is something else which we have not accounted for. So a group of scientists thought that the second is true, that there is something else which we have not accounted for. And they thought about that maybe there is another planet nearby which is very heavy, and that planet is disrupting the orbit of Uranus a little bit. And they looked at how much that disruption is happening. And then based on that, they did a mathematical calculation that where this planet should be and how far away it should be and in which direction it should be. So they did all this calculation. They took a telescope, looked into that direction and found Neptune. So Neptune actually was discovered first on a piece of paper with help of some mathematical equations. And now we know that of course it is there. Same thing had happened for Mercury also. That Mercury orbit was not exactly what Newton's law is predicting. So many scientists thought the same, that maybe there is a planet near to Sun compared to Mercury. And since it is so close to Sun, in the brightness of Sun, we are not able to see this planet. And maybe this planet is affecting the orbit of Mercury around Sun. But Einstein thought otherwise. Einstein thought that Newton is not correct. Einstein thought that Newton's theory of gravity needs a modification. And he developed this better theory called general theory of relativity, which by the way, there was a question asked by UPSC on that topic also. And that general theory of relativity now provided this insight that why Mercury orbit is little bit different than what Newton is saying. So we have now a better theory of gravity, which we call general theory of relativity. Right? So that is how science progresses. That either you think that you do not know everything, some data is missing, or you need to find a better theory. So when we look at the movement of stars around the center of galaxy, so think of Milky Way galaxy. At the center of Milky Way galaxy, there is a supermassive black hole called Sagittarius A. And the same way Sun allows planets to revolve around it. This supermassive black hole is so dense and massive that these billions of stars are revolving around the center of galaxy. Right? So if I apply Newtonian's theory or Einstein's theory also, the stars which are very far away, they should revolve much more slower. And the stars which are very close to the center of galaxy, they should revolve much more faster. The same way Earth and Venus revolve faster than Jupiter and Uranus and Neptune. So we can think of the same, because after all the mathematics it's same. So when people collected the data about the revolution of stars, they found out that even these very distant stars are revolving as fast as stars which are very close to the supermassive black hole. So this is now an anomaly. Our existing theory cannot explain that why is it happening. And there are many such anomalies. I have told you the most famous gravitational anomaly, but there are many more. And then scientists are divided into two groups. A group of scientists who believe that जो न्यूटन का gravitational theory है, it needs modification. और Einstein's का जो gravitational theory, it needs modification. But majority of scientists believe that there is a group of particles in universe which have mass, but they are chargeless, and since they are chargeless, they are not affected by electromagnetism. They're also not affected by, maybe they are also not affected by strong interaction. But since they have mass, they can cause gravity, and they are affected by gravity. So this gravitational anomaly you see is because of this matter we call dark matter. But dark matter is only a theory. Till date, it remains a theory. We do not know if dark matter is actually out there. So why neutrino detectors can help us in knowing about dark matter? Because one of the most famous theory that if there is dark matter, then what it is? And the most famous theory is that it is also a matter which is only affected by weak interaction and gravity, same as neutrino. So if we understand about neutrino, maybe that will allow us to know more about dark matter. So that is why often whenever about neutrino detector, if there is a statement that it also aims to know more about dark matter, that statement will be correct. But यहाँ पे I will repeat this word telescope is problematic. But nonetheless, answer is first, second and third. 1, 2 and 3. If you have question here in this topic, you can ask questions. Let's go to the next question then. 3, 4 questions together I can discuss. This theme of gravitational wave has been asked by UPSC many number of times. What is the purpose of evolved laser interferometer space antenna? The answer is to detect gravitational waves. B is the correct answer. Recently, so that was 2017. This is 2019. Recently, scientists observed the merger of giant black holes billions of light years away from the Earth. What is the significance of the observation? Gravitational waves were detected. So here also B is the correct answer. And in 2020, the experiment will employ a trio of spacecraft flying in formation in the shape of an equilateral triangle that had sides 1 million kilometers long with lasers shining between the craft. The experiment in question refers to that ELISA which UPSC asked earlier in 2017. So the answer here is D, evolved LISA, which aims to detect gravitational wave. So all of these questions are related to each other. Gravitational waves have been in news a lot, and even though again this topic is prima facie a difficult topic, but UPSC is not asking some like great technicality here. They're simply asking about what this experiment is or what it aims to do, like things like that. So let's briefly talk about all of these things together. In fact, one more topic I can discuss together, 4 questions I can discuss together. There was a question asked by UPSC in 2018, I think. Consider the following statements. Light is affected by gravity. The universe is constantly expanding. Matter warps its surrounding space-time. And then the question is that which of the above is our predictions of Einstein's general theory of relativity often discussed in media. देखो UPSC ने last में भी लिख दिया था कि ये ऐसे ही नहीं पूछ रहे हैं. This is actually discussed in media, right? So anyways, this was actually discussed in media. They are not lying. This was discussed in media, and why this was discussed in media in that year, I'm going to discuss that also. Answer is D here, 1, 2 and 3. The correct answer will be 1, 2 and 3. Okay, so let me briefly now explain all of these topics together. So why Einstein is considered one of the greatest scientists along with Newton? So two of the brightest minds which this planet had seen will be Sir Isaac Newton and Albert Einstein. Right. So Newton, even though many of his theories are have been modified, but he developed things when there was almost no knowledge. Like he developed everything from grassroots level, and even though many of his ideas have been modified, he's considered the brightest mind. But Einstein, already science was well established, discipline, scientific method was well established, but Einstein was able to imagine things which people were not able to do that. And when Einstein gave his theories, so he did many things, but he's remembered for the two things. The first is called special theory of relativity, and the second is called general theory of relativity. And when he gave his theories, very few people understood it, and even fewer people thought it to be correct. And then there was no way to confirm if he was actually, whatever he was saying is correct or not. Now we know that almost everything he said was correct. In fact, he said everything correct. The only thing is that few things he was not able to figure out. But the things he was not able to figure out, even today we have not been able to figure out. What are those things he was not able to figure out? So anyways, Einstein gave his first theory in 1905, which is called special theory of relativity. Special theory of relativity is essentially based on a fundamental law of physics, that speed of light remains the same in all frame of reference. Right. So there are certain laws of physics which are independent of frame of reference. Jaise, if I say that energy is conserved, then for everybody energy is conserved. No matter if I am here or somebody is on Mars or somebody is traveling with very high speed, doesn't matter. Energy is conserved, energy is conserved. It doesn't matter upon your frame of reference. Few things matter on your frame of reference. For example, if I ask you that how far you are, right? तो अब देखना पड़ेगा कि किसके हम रेस्पेक्ट में बात कर रहे हैं. For you, for me, आपका कोऑर्डिनेट कुछ अलग है, उनके लिए कुछ कोऑर्डिनेट अलग है. So there are few things which depend upon in which frame of reference you are. But then there are things which do not depend upon your frame of reference, right? So even before Newton, there was a scientist named Galileo. We all know Galileo as inventor of telescope, although he did not, but he did use it to very large extent. So Galileo talked about this idea for the first time, that there are certain laws of nature which will remain the same independent of the observer. फर्क नहीं पड़ता है कि कोई ऑब्जर्वर है, कौन से फ्रेम ऑफ रेफरेंस में है. These laws will be the same, right? Newton said the same thing. Einstein also said the same thing. So Einstein did not say anything new in that statement. What he said, that second statement that was new, that speed of light is one of that law. So first, Einstein's special theory is based on two postulates. The first postulate is that laws of physics, they are independent of frame of reference. And the second postulate is that one of that law is speed of light, which essentially means that if there are, let's say, two objects A and B, two observers moving with same velocity in a straight line, then I will say that the relative velocity is 0, isn't it? जैसे for example, आप ऐसे समझ लो, we all are moving because Earth is rotating and revolving. But since we all are moving with same rotation and revolution, then we are at rest with respect to each other. So this is what it logically makes sense, that relative velocity in this case will be 0. In this case, however, when this is velocity in two different directions, then A will measure velocity of B as 2 times V, and B will measure velocity of A as 2 times V. This is called relative velocity. But then Einstein says that this needs a little correction. Even that 0 is not correct, but it is almost 0, so we can ignore it for lower speed. What Einstein said, that if your speed keeps on increasing, then whatever logical intuition you have developed, that it's simply going to be wrong. It's not going to help you. So Einstein says that if this V becomes C, that let's say there are two light photons, and photons travel with speed of light. Speed of light is often shown with this constant small c. C is 3 lakh kilometer per second. And two photons in the opposite direction. Then as per our logical intuition, the relative velocity here should be 0 and the relative velocity here should be 2 times c. Einstein is saying that both are wrong. Here also it will be c and here also it will be c. So, जो speed of light है, that remains the same in every frame of reference. And that does not make sense. But then Einstein says that it happens because you have till now thought of space and time as two independent things. But they are not. Nobody had thought of this. Right? Newton never even thought of this. In fact, before Einstein, nobody thought of this. That time is dependent upon space and vice versa. So what Einstein now says, that if something is traveling with, let's say, very high speed, half of speed of light, उनके लिए जो length है वो कम होगा. उनके लिए, so we use things like length contraction. जैसे मान लो, अभी तक हमने ये पढ़ा था, that अभी हमने एक point discuss किया that if I, let's say this is my some frame of reference, there is some observer O here, and there is frame of reference observer O dash here. And let's say that on one point they will not agree to, that is point का coordinate क्या है, ये point कहाँ कितना दूर है, they both will disagree. But अभी तक हम ये तो मान के चल सकते हैं ना कि अगर दो point का distance निकालना हो, तो ये दोनों बोलेंगे कि distance मान लो कुछ L है, they both will measure this as L, right? So for example, in the question I asked that what is his coordinate, and that answer is dependent upon where I am and where you are. But if I have to say that what is the distance between these two people, then no matter who measures it, the distance will be same. Einstein says that no, it will not be same. Einstein says that this distance will differ. That distance will depend upon how fast you are moving. So your speed decides the distance between 2 points. And the same thing, if I drop this pen and I caught this pen in my hand, then let's say this event happened in 1 second. So before Einstein, everybody will say that this event happened in 1 second. Everybody will measure this 1 second. कोई भी measure करे universe में will measure this event in 1 second. Einstein said that this is also false. That this is not 1 second. This depends upon how fast you are moving. If you are moving very fast, what time you'll measure? Maybe it is 1 second in your frame, but somebody who is stationary, somebody who is not moving fast, will measure the same event in separate time. So the consequence of light being at constant speed in all frame of reference is that space and time, which we think of separate entities, that we live in a three-dimensional space, and then time. So now Einstein says that we actually live in a four-dimensional world, where 3 dimensions are spatial coordinate, but the 4th dimension is time. Although there is very like weird property of time, that while in space I can go up, down, left, right, sideways, but in time I always seem to go in forward direction. I cannot go back in time. So in that way, time dimension is little different, but space and time are very much dependent upon each other. So this is what Einstein says in special theory of relativity. It leads to what we call length contraction. If I have to talk about the consequences of special theory of relativity, it leads to what we call length contraction, that the measurement of length will not be same. It leads to time dilation. In fact, it also leads to E is equal to mc squared. That same law which says space and time are not independent of each other, the same law also tells us that mass and energy are also not independent of each other. Mass and energy are very much dependent upon each other, and I'm very sure that you have come across this equation E is equal to mc squared somewhere. All of that is consequence of special theory of relativity. But then 10 years later, Einstein published another paper. In 1915, he published this paper called General Theory of Relativity. And in General Theory of Relativity, now he provided a better theory of gravity. So General Theory of Relativity का जो सबसे fundamental जो point है, that not only space time are same, like they're dependent upon each other, but they're affected by gravity. That a very heavy object, it warps space time around it. The same way, for example, let's say आपने किसी surface पे बहुत tightly कोई cloth बांध रखा है, and you put something very heavy onto it, and it causes a warp here, right? So Einstein thought that now imagine the same thing in 3 dimension or 4 dimension for that matter, because space time is 4 dimension. An object which is very heavy will warp. So around this object, the space time interval will be less, and as we go further and further, it will be more and more. So what you think of a gravitational force, we think of gravity as a force, but in Einstein theory, it does not have to be a force. In Einstein's general theory of relativity, gravity may not be a force. Gravity simply be a consequence of curvature of space-time, which is shown here. This is a more heavy object. This is a less heavy object. That more heavy object causes a bigger curvature compared to a less heavy object. And when this object comes in this curvature, then it starts moving in this curvature. And this is what Einstein says that causes what we call gravity. So not only space-time are same thing, space-time is affected by gravity, which means that the length interval I'm going to measure on sun, what is 1 centimeter on sun is not 1 centimeter on earth. And what is 1 second on sun is not 1 second on earth. So time progresses differently depending upon how much massive object you are, where you are exactly. So around a black hole, time will progress differently. Around a very heavy star, time will progress differently. Around an average star like sun, time will progress differently, and around earth it will progress differently. So it's not that space and time are just dependent upon each other, or they are same thing. Space-time curvature is essentially dependent upon mass. So this is what Einstein says in his general theory of relativity. And general theory of relativity led to many consequences. Of course, the first is that space-time is affected by gravity. So we have studied that light always travels in a straight line. हमने पढ़ रखा है. But if light is traveling in a straight line in space-time, but what if space-time in itself is curved? Right. So if space-time in itself is curved, you'll not find light traveling in a straight line. You'll find light bending towards gravity. Whenever there are very massive objects, because of those massive objects, even light is going to bend. Right. So light is affected by gravity. That was the first statement which was asked by UPSC. That is a correct statement. Why? Because this heavy object has warped, folded the space-time around it. And light is actually traveling in a straight line. The problem is that space-time in itself is curved. And because of that, we are going to perceive this light that it is being bent by gravity. So that third statement was also true, that matter does warp space-time around it. Just say in this case, I have shown this picture of a phenomena which is called gravitational lensing. Gravitational lensing occurs that मान लो एक बहुत दूर गैलेक्सी है, ये अर्थ है, some billion light year away, there is a galaxy. This galaxy is so far away that the light coming from this galaxy before it can reach to Earth will be so faded that we'll not be able to see this galaxy. Right? That's very obvious. कोई भी बहुत powerful optical instrument है, but every optical instrument has some resolving issue. That बहुत ही dim अगर light हो, it will not be able to find the image. But just by chance, there was cluster of galaxy or galaxies in between. And the same way, a lens can converge light. आपने पढ़ रखा है ये? Remember your class 9th or 10th optics class, that a convex lens or a concave mirror converges light. So the same way a lens converges light, because of the gravitational distortion here, because of the curvature of space-time, this light can converge now. And because of that convergence, a telescope here will be able to see this galaxy very, very far away. So this phenomena is called gravitational lensing, which is a direct consequence of the fact that light is affected by gravity. Einstein theory also explained that black holes can exist. Einstein theory also came to a conclusion that universe is expanding. And when this was a conclusion made by his theory, Einstein thought that this is not correct. Einstein thought that there is something wrong with his theory. It needs correction. And later, when scientists actually looked at the distant galaxies with help of telescope, and they found those galaxies moving far away and far away from each other, and this was confirmed that universe actually is expanding. So Einstein's reservation about his theory was proven wrong. His theory was proven right, that universe is expanding. So, and by the way, why this topic was covered in media? Because some 100 years had occurred of general theory of relativity, particularly about the Einstein statement where he considers his life biggest blunder was to doubt his theory, that he had doubted his theory, and then he goes on to say that that was his biggest blunder, right? So in any case, and that is why this was covered in detail in newspapers, and theory of relativity was covered in more detail, and UPSC made a question on it. So there are many consequences of general theory of relativity, that matter warps space-time, black holes can exist, light is affected by gravity, gravitational lensing, but it also leads to one more conclusion, that gravitational waves can exist. 3 questions on gravitational wave in last 10 years. So gravitational wave exists. What is a gravitational wave? Think of a wave. Wave is some sort of vibration. If it is a sound wave, it is vibration of air or some other medium. If it is a light wave, then it is electric and magnetic field which is vibrating. Electromagnetic field propagating in space. But when I use the word gravitational wave, it is not about propagation of something in space. It is space-time curvature in itself is vibrating. That whenever gravitational wave passes through, it means that space-time curvature is coming closer to each other and going away from each other. So it is not something passing through space. It is space-time curvature changing in a periodic manner as this gravitational wave passes through. This occurs because of very high massive objects if they are accelerating, or a sudden production of huge amount of energy which can produce gravitational wave. Theoretically, even sun can produce gravitational wave, even earth can produce gravitational wave theoretically, but that gravitational wave is going to be so weak that we will not be able to detect it. But there are events in universe which are called cataclysmic events, like pralayakari events जो है, 2 black holes आपस में merge कर गए, 2 huge black holes, and they merged together. A very heavy star went supernova, started exploding, produced so much of energy that for a brief moment it outshined the entire galaxy. This event is called supernova. So these events can produce now the scale of energy and the gravitational wave which will be so powerful that this can be actually intercepted even though they occurred millions of years ago. So the question which was asked by UPSC, that recently scientists observed the merger of giant black holes billions of light years away from the Earth. What is the significance of the observation? That produced a gravitational wave which was detected on the Earth, and it was detected with help of a setup that is called LIGO, Laser Interferometer Gravitational Wave Observatory. And this topic is important because as of now, Government of India has given approval of a LIGO setup in India. It is an under construction facility in Hingoli district of Maharashtra. तो टॉपिक इसलिए भी इम्पॉर्टेंट है लाइगो के बारे में, दैट गवर्नमेंट ऑफ इंडिया भी अप्रूवल बजट सब कुछ फाइनलाइज है. द प्लान इज दैट बाय 2030 we will have our own LIGO experimental setup which is going to collaborate with other LIGO setup of the world. So what is this LIGO setup? LIGO setup essentially is this L-shaped two big arms. I may have a picture of this. I do not have a picture, actual picture, but this will be this 4-kilometer big arm. There will be mirrors here. These mirrors will, and there will be some light producer here. So it is going to produce light, but there will be a mirror here. And this mirror will divide this light into two parts. Half of the light will go here, half of the light will go here. This mirror will have 100% reflectivity. So this light will be reflected from here, this light will be reflected from here. And this two light will now interfere together. Hence the word laser interferometer. It is an interferometer. It is going to cause interference of light. Now, since this distance is same, 4 kilometer, this distance is same, this two light is going to come back at the same point, and that will cause some sort of interference pattern. But if this distance changes, then this interference pattern will be some different pattern. Now, how can that distance change? This distance can change, let's say, because of some thermal changes. Temperature अचानक से बढ़ गया and thermal expansion हो गया, या बहुत कम हो गया, thermal contraction हो गया. So we should choose first a place where temperature difference is not that much. We should choose the materials which do not expand and contract that much with temperature. And even then, we need to isolate them in a way that the heat transfer between the setup and the outside is very less. So we can remove that part. The second problem which can increase the length or decrease the length can be earthquake or landslides. Then choose this setup in places which are not prone to earthquake. And in any case, we can always detect an earthquake, that if earthquake has occurred or not. Or there can be a way how this length can change is if a gravitational wave has passed by. Because if a gravitational wave has passed by, remember, gravitational wave causes space curvature to come together, space interval to come together and go away together. So anything, whatever it passes through, their length changes periodically. The length increases and the length decreases. So if a gravitational wave has passed by, then this arm length will decrease and this arm length will increase. And the next instant, this arm length will decrease and this arm length will increase. This will be a very specific interference pattern. And by the way, just in case that you still want to ensure that कोई और variable के कारण ना हुआ हो, then have more setups. Have one in Louisiana, have one in California. So this was a setup made in America. And in 2015, it announced that we have detected gravitational wave. So it was theorized by Einstein 100 years ago in 1915. But it was discovered for the first time in 2015, 100 years later. And the person who thought of this setup, Kip Thorne was given Nobel Prize in Physics just next year. In 2016, Nobel Prize was given to Kip Thorne. Kip Thorne is the person who also wrote the script of movie Interstellar, if you have watched that movie. So anyways, this is LIGO setup. अब इसका एक और जो यूरोपियन स्पेस एजेंसी का एक बड़ा ग्रैंड सा प्लान है, एंड दैट ग्रैंड प्लान इज इवॉल्व्ड लीसा, कि अर्थ पे, लेट मी कंप्लीट दिस, आई विल आंसर क्वेश्चंस. व्हाट यूरोपियन स्पेस एजेंसी हैज थॉट दैट ये 4 किलोमीटर का जो डिस्टेंस चेंज होगा वो फिर भी बहुत कम होगा. So what they plan to do, they plan to launch 3 satellites with again mirrors around sun now, not around Earth. And these 3 satellites will make 3 sides of an equilateral triangle. तो इनका position sun के around ऐसे होगा that all the time they are going to make an equilateral triangle, और equilateral triangle का जो side होगा वो कुछ 1.5-2 million किलोमीटर का होगा. And all the time they are going to send light signal to each other. If a gravitational wave has passed by, then this 4 million kilometer length will change much more compared to a 4 kilometer. So 1 million kilometer length will change much more compared to 4 kilometer on Earth. So that is the plan of European Space Agency, and this experimental setup is called ELISA. अभी तक ये launch हुआ नहीं है, ये 2030 या 2035 तक launch होगा. So the answer here is D, that employ a trio of spacecraft flying in formation in the shape of equilateral triangle. In fact, it is not even 1 million, it is more than 1 million kilometer long. The answer is D here. So all of these questions are based on similar set of concepts of gravitational wave or Einstein's theory of relativity. One more thing which you should know about gravitational wave is that they travel with speed of light. Hanji, you had a question. Because it travels, gravitational wave travels with speed of light, so you can say that almost same time, if not same time. Japan और India के बीच में कितना ही distance है? Okay, so that is why more than one setups is required. That if a gravitational wave has passed by Earth, then all LIGO setup will show the exact same interference pattern. The reason why there are more than, and by the way, it's not just in Japan and India and US, it is also in Italy, it is also in Germany. And if a gravitational wave has passed by Earth, then all of these setups will show the same interference pattern with a difference of fraction of second, because gravitational wave travels with speed of light. So then we can ignore or we can filter out that earthquake part also, right? कि earthquake हर जगह same type का earthquake हुआ है. That is again not going to happen. Any other question? Okay, so LISA Pathfinder was a plan launched by again ESA to explore that if it is possible or not. That एक बड़ा setup करने से पहले आप छोटे मोटे जो experiments करते हो. So the answer is yes, that evolved LISA is their main plan, but before they can launch evolved LISA, they said they sent some experimental setups that is it possible, and all of those experiments were called LISA Pathfinder. So the answer is yes, but इस question का answer जो है evolved LISA है. Any other question? Which one? C option, sorry, C option जो wormhole वाला option है. No, we do not have any setup to detect a wormhole. Wormhole is a place where space-time is folded in a way that I can travel millions of kilometers in like matter of fraction of second. That gravitational anomaly is so high, often people use in movies जो दिखाते हैं, तो मैं आपको दिखा देता हूँ कि जो space-time curvature अगर ये है, तो some gravitational anomaly allows this curvature to fold like this. So if I have to go from this point to this point, then I have to take a path, right? But if because of gravity the space-time is folded in a way, then with help of this wormhole I can go from this point to this point in matter of second. This is allowed by Einstein's theory. Wormhole theoretically can exist, but do they exist? First of all, we do not know. Do we have a setup to determine that? Not at all. Yeah, if this happens, it will be because of gravitational anomaly of some massive object that is there. Or maybe some other way we have figured out how to create artificial gravity so powerful that it can produce a wormhole. That is the plot of Interstellar movie. Okay. That's a Hadron Collider. That's a separate thing. That's a separate thing. Okay, so let's go and see the next question. There was one more question here. The term event horizon, singularity, string theory, standard model are sometimes seen in the news in the context of. The answer here is observation and understanding of the universe. So ऐसे क्वेश्चन का बेस्ट पार्ट ये भी एक होता है कि यूपीएससी बहुत सारे टर्म्स थ्रो करती है, एंड इवन इफ यू नो अबाउट वन ऑफ देम you can get the answer. But if you do not know about any of them, then you should not attempt such questions. Right? If you have no idea that what these words mean, then you simply should not attempt such questions. But these are very popular words. All of the words which are mentioned here, they are very popular. They are covered by news. साल भर अगर आप न्यूज़पेपर पढ़ोगे तो आपको इन चारों में 2 वर्ड तो पक्के से मिल जाएगा, या हो सकता है चारों भी मिल जाए. तो है क्या, एक बार ब्रीफली देख लेते हैं विदाउट लाइक गोइंग इनटू लॉट ऑफ डिटेल. Singularity is this concept in cosmology, in physics, that you can think of singularity as all of the mass concentrated in zero volume, which essentially will mean infinite density. And in mathematics, infinite is good. In physics, it is not good. No physicist will say that there is somewhere there is some infinity. Singularity is considered. So, जो हमारा existing laws of physics है, आइंस्टाइन का जो थ्योरी है, एज पर आइंस्टाइन थ्योरी सिंगुलैरिटी एग्जिस्ट एट द सेंटर ऑफ ब्लैक होल, और एज पर आइंस्टाइन थ्योरी यूनिवर्स स्टार्टेड फ्रॉम सिंगुलैरिटी. सो दैट बिग बैंग विच वी से दैट स्टार्टेड फ्रॉम सिंगुलैरिटी, इनफाइनाइट डेंसली ऑब्जेक्ट exploding at very high energy, leading to formation of universe as we know of. Right? So this only tells you that we do not understand singularity. So I said that Einstein was not able to figure out few things. This is one of those things. So हमारे जो existing laws of physics हैं, they completely break down the moment we go at the center of black hole. Right? So the understanding of singularity will perhaps allow us to understand more about evolution of universe. So, but rest of the black hole we still can at least mathematically describe. You cannot mathematically describe singularity, but rest of the black hole you can mathematically describe. That if this is black hole, then there is a region around black hole which is called event horizon, and inside event horizon the escape velocity is more than speed of light, which essentially mean that even light cannot escape. And by the way, आइंस्टाइन का जो स्पेशल थ्योरी ऑफ रिलेटिविटी है उसका एक और कॉन्सिक्वेंस ये भी है, दैट नथिंग कैन ट्रैवल विथ फास्टर देन स्पीड ऑफ लाइट. देयर इज अ मैक्सिमम बैरियर, एंड दैट बैरियर इज स्पीड ऑफ लाइट, एंड only massless particles can travel with speed of light. The moment there is some mass is also not constant. As you travel faster, your mass increases. So there are certain particles which are massless particle, and those massless, such as photon, they are the only particles which will travel with speed of light. As a proton can never travel with speed of light. Electron can never travel with speed of light. Neutrinos are almost massless, so their speed will be very close to speed of light, but again not speed of light. But it will be like 0.999999999 in C, ऐसे कुछ होगा, not exactly speed of light. So anyways, inside event horizon, the escape velocity, the gravitational force is so powerful that escape velocity is more than 3 lakh km per second. On Earth, it is 11.2 km per second. Right? Her object, depending upon the mass, right, or mass कितना concentrated है, escape velocity is decided. Black hole की case में it is more than 3 lakh km per second. So this region around black hole is called event horizon. The moment you are part of event horizon, you cannot escape. There is no possibility of any escape after you are part of event horizon. Okay. The two more words which are given is string theory and standard model. So people have always wondered about that, are we made of something fundamental? That हम जो चीज़ें देख सकते हैं अपनी आँखों से, but अगर हम चीज़ों को divide करते चले जाएं, that do you come across at some juncture where you cannot see further, you cannot look further. So I will call that as the fundamental scale of the universe, right? जैसे we know that whatever matter we know, it is made of molecules. ये सबने पढ़ रखा है. We also know that all molecules are made of atoms. We have learned that also. We know that all atoms are also made of these three particles we call neutron, proton and electron. And we know atomic structure that neutron and proton are at the center of atom in a very dense object called nucleus, while electrons can be thought of as revolving around nucleus. ये सबने हमने पढ़ रखा है. But then we ask a question that have we found fundamental particles? Have we found that I cannot go any further, that everything is made of neutrons, protons and electrons? तो अभी तक जो हमारा अंडरस्टैंडिंग है, जो हमारे पास प्रॉपर एविडेंस है उसका, we have experimentally confirmed it, that electron is a fundamental particle. That electron actually is a fundamental particle. We cannot see inside electron, but protons and neutrons are not. If the same way molecules are made of atoms, atoms are made of protons, neutrons, electrons, if you see a neutron or a proton, you see three more particles which are called quarks. So protons, neutrons are made of a more fundamental particle which we call quark. यहाँ पे हमारा जो understanding है यहीं पे खत्म होता है. अब when we explain nature at very larger scale, we use general theory of relativity. By the way, this description of fundamental particles and the fundamental forces, gravitational, not gravitational force, but electromagnetic force, strong force, weak force, this together is called standard model. That was another word. That what is? Standard model. So standard model is what I just described, that a description of fundamental particles and fundamental interactions. So standard model tells us about subatomic particles. Protons, neutrons, electrons. It tells us that protons and neutrons are made of quarks. Electron is not made of anything else. So I can think of electron and neutrino and protons and quarks as fundamental particles, not protons, quarks. But there is a problem in standard model. Standard model does not include gravitational force. And gravitational force का जो theory है वो general theory of relativity है. So if you try to combine standard model with general theory of relativity, these two theories are very popular, very accurate in their own domain, but any attempt to combine them has been proven to be futile. Why do we need to combine them? To explain singularity. जो हमने just पहले अभी discuss किया थोड़ी देर पहले, that the center of black hole which is infinitely dense but also very small, to explain that we need a theory which can explain general theory and standard model, which essentially is based on quantum mechanics. So standard model, quantum mechanics and general theory together, all these efforts have been proven to be futile. But that does not mean there have not been any effort. The most popular effort is called string theory. So string theory का जो fundamental, without going into again lot of detail, string theory का जो fundamental notion ये है, that what we think of quarks and electrons and neutrinos, if somehow we could see inside them also, we will find strings vibrating. And as those strings vibrate at different frequency, they produce different particles. So there is nothing called particle per se. Everything is simply vibration. Vibration of some, again, don't think of string how we think of string in our day-to-day life. This is a quantum string. It is only mathematical as of now. And as it vibrates at different frequency, it produces different particles. And those particles come in some combination due to some fundamental forces such as electromagnetic force or weak force or strong force. And they form atoms and molecules and matter. So string theory is a theoretical description of nature at the most fundamental scale. But it is only a theory. There is no way to confirm if any of it is true. Maybe it is entirely wrong, right? Maybe it is entirely correct. Maybe it is partially correct. But we simply do not know that if it is entirely correct or if it is entirely wrong or if it is partially correct or partially wrong, right? So, but this is a description of nature called string theory, right? So, but हमारा जो अभी जो understanding है वो यहाँ तक है, वो यहाँ तक limited है, that things are made of quarks and leptons. One of the lepton is electron. So this is what UPSC did ask, all of these 4 words, and the answer here is observation and understanding of the universe. Any questions if you have? You can ask questions now. Not exactly the same thing. Ergosphere can be thought of as lot of photons and particles swirling around black hole very far away from event horizon. So event horizon का radius अगर r है तो ऐसे समझ लो कि बाकी जो भी चीजें ब्लैक होल के अराउंड जो एग्जिस्ट कर सकती हैं विदाउट बिकमिंग पार्ट ऑफ इवेंट होराइजन, दे विल हैव टू बी लाइक मोर देन 4 आवर और 5 आवर थिंग ऑफ थिंग, बहुत काफी फार होना होगा उनको इवेंट होराइजन से. एनी अदर क्वेश्चन? स्ट्रिंग थ्योरी, सॉरी क्वेश्चन क्या था? So standard model is a well-established theory with lot of experimental evidences. Many things are clear about standard model. String theory goes one step ahead of standard model. Standard model cannot explain few things. For example, standard model cannot explain gravity. String theory explains standard model and gravity together. At least in a theoretical form, it does the both things together. Is it correct or not? We simply do not know. Okay. बाकी क्वेश्चन अब आसान है. अब जो भी क्वेश्चंस है वो इजी है. So let's look at some more questions. There is a question based on some of the famous experiments. Bell 2 experiment, blockchain technology, not experiment but technology, and CRISPR-Cas9 technology. But this was a very easy question because if you know that CRISPR-Cas9 is gene editing, then you do not have to even worry about the first statement. CRISPR-Cas9 is gene editing, not particle physics. Eliminate 3, you have your answer 2. And 2 is correct also. Blockchain technology is for cryptocurrency or can also be used for digital currencies in general. So 2 only is the correct answer. Bell 2 experiment is a particle physics experiment. ये जो particle physics यहाँ पे दे रखा हो यहाँ पे आएगा. There is a very specific particle called meson particles. And Bell 2 experiment aims to understand more about meson particle. It is a setup located in Japan. This is the experimental setup of Bell 2 experiment. And this question should not be attempted if I change the question in the current pattern. How many of them are correct? So I know third to be wrong, I know second to be correct, but if I do not know the first, right, then that can be a problem. So that you have this 50-50 wala jo cheez hai. So that will be a little bit, not little bit, 50% risk. So that will be 50% risk. That's totally up to you if you want to attempt or not. But in this pattern, this is a very easy question. Answer is 2 only. This was also a question inspired by current affairs. The word Denisovan, sometimes mentioned in the media, is in reference to an early human species. जो हमारा complete नाम है हमारे species का, वो है Homo sapiens sapiens. Homo sapien is the genetic group. Homo sapien, sapiens is our species name, right? But जो हमारा immediate larger classification जो होगा, I will call it this Homo species, or in fact Homo sapien species. So you have Homo sapien Neanderthals, or you have Homo sapien Denisovans, but turns out that those species did not survive. The Denisovans became extinct, Neanderthals became extinct, but we also know that in past Homo sapien sapiens, which we are, and Neanderthals and Denisovans, that definitely partied together. How do we know that? Because in many parts of the world, when we do the genetic analysis, then we find Denisovan DNA. In Siberia, for example, the Denisovan DNA is 3 to 4%. Many Europeans have Neanderthal DNA of 2 to 3%. So it's very clear that even though sapiens and Neanderthals may have entered into conflict also, but they also lived together, right? And that genetic trace still is found in, not across the humanity, but depending upon in which part of the world you are, there can be a chance of Neanderthal DNA or Denisovan DNA. So this topic often is in news because if you have found some early hominid species genetic sample and you do some genetic analysis, and based on that you try to learn more about our closest evolutionary ancestors, all of them have become extinct as of now. So the answer here is an early human species. This was one of the easiest question. Like 9th, 10th biology में आप पढ़ते हो, the difference between plant cells and animal cells. Plant cells have cellulose cell walls, whilst animal cells do not. Plant cells do not have plasma membrane, while animal cells do. Mature plant cells have one large vacuole, while animal cells have many small vacuole. That second statement is not correct. First statement is correct. Because of that cellulose wall, plant cells are rigid and plants cannot move. Since we do not have that, we are much more flexible and we can move. So first is correct, third is correct, second is not correct. जो plasma membrane structure है, that gives protection to all eukaryotic organism, चाहे वो plant cells हो, चाहे वो animal cells हो. So ये बहुत आसान question था. Here answer was 1 and 3 only. If you look at the structure here, right? So vacuole, that one large vacuole versus many small vacuoles. Plasma membrane, cell wall, that is absent here. But plasma membrane is present just inside this cell wall, plasma membrane, and plasma membrane here, that is present in both the cells. There are many more differences, presence of chloroplast, or many other things, but UPSC did not even go into a lot of detail here. They asked a very simple question and eliminate second option, and you have your answer. Right, so there are many differences. Both have mitochondria, but only plant cells have chloroplast. Both plants and animal cells have vacuoles, but again there is a difference. Plant cells have a cell wall. Animal cells simply have a cell membrane, but no cell wall. We know about these things. Okay, this was a fantastic question. For me, this is like one of the best questions asked by UPSC. And so many people got this wrong, right? We got it right. So I was very proud of that we got this answer correct. Many people thought that UPSC has given wrong answer after answer key was released, but they did not give the wrong answer. Right? Your understanding is simply not accurate. This question is that in a pressure cooker, the temperature at which the food is cooked depends mainly upon which of the following? The first option is area of the hole in the lid, temperature of the flame, weight of the lid. Everybody gave the answer as D. We gave the answer as 1 and 3. That second is not at all true. Temperature of flame will not determine that what temperature inside the cooker food will be cooked. Exactly. So let me first explain. This is not that simple. Like, it's also simple if you understand the basic concept of thermodynamics. One of the goals of thermodynamics is to study the heat transfer. In a thermodynamic system, we divide universe into two parts. We first describe a system, and then we describe a surrounding. And then we see, for example, let's say I have to understand my energy transfer mechanism with the surrounding. I am a system, and the rest of the universe is surrounding. Then in thermodynamics, we will try to understand that what are the processes through which energy is being produced inside my body, and how that energy is being transferred from the surrounding. But is it only energy? Are we also transferring matter to the surrounding? So we divide our thermodynamic system depending upon if you are neither transferring matter nor transferring energy, we call this isolated system. If you are only transferring energy but no matter, we call it closed system. If we are transferring both energy and matter, we call it open system, right? So let me give example of all of that. So for example, you can think of isolated system is very rare, but if you want to imagine isolated system, imagine some thermally resistant material kept into vacuum somewhere, right? It's an ideal situation. Saying that something is completely isolated is an ideal situation. There are many open systems. Think of, for example, water in a pipeline, that this water is coming down, but this water carries energy. So जो पूरा pipeline अगर मेरा एक system है, so matter is also coming out, energy is also coming out. But pressure cooker is an example of closed system. That in pressure cooker, most of the transfer which happens is energy. Matter transfer does happen when that CT जब ऊपर जाएगा, then that gas does come out. But most of the time, the thing which is being transferred between the system and surrounding is essentially energy. Okay, so what is the source of energy? Source of energy is that flame. That हमने gas चूल्हा को जलाया, flame is at some temperature, and that provides the energy. अब फ्लेम टेम्परेचर खाली ये डिसाइड करेगा कि जो अंदर का पानी है वो कितना जल्दी वेपराइज हो गया है, बट वाटर का जो बॉइलिंग पॉइंट है वो डिसाइड होगा कि अंदर प्रेशर कितना है, और अंदर प्रेशर कितना है ये इस बात पे नहीं डिसाइड होगा कि फ्लेम टेम्परेचर कितना है, अंदर प्रेशर कितना है ये इस बात पे डिपेंडेंट होगा दैट ओवरऑल आपका लिड कितना हैवी है. इफ लिड इज वेरी हैवी, सो प्रेशर कुकर पहले तो काम कैसे करता है देखो. प्रेशर कुकर इज अ क्लोज सिस्टम. It increases the pressure inside this cooker, and because of that we know that boiling point of water is a function of temperature but also pressure, that at high pressure the boiling point increases and at low pressure boiling point decreases. अब पहाड़ों पे ऊपर चले जाओ, वाटर जो है 70-80 डिग्री सेल्सियस पे बॉयल हो जाएगा. यहाँ पे we need 100 degree Celsius. When I say 100 degree Celsius, then I assume 1 atmospheric pressure. And if you are on the surface of Earth, you can assume 1 atmospheric pressure, no problem there. But inside a cooker, that pressure is very high. And inside a cooker, the boiling point of water goes as high as 120-121 degrees Celsius. So the cooking actually is happening at very high temperature. That water is at very high temperature, but is not escaping. It is still water, it is still liquid, right? And liquid at high temperature will carry much more energy. Gas will spread. So you have created a closed system where pressure is very high, and because of that, boiling point of water is very high, and your food gets cooked easily. But वो pressure regulate कैसे हो रहा है? Pressure regulate हो रहा है आपका जो vessel है उससे. कि अगर pressure infinitely बढ़ जाए तो पूरा फट जाएगा. We do not want that to happen also. Pressure maintain भी तो करना पड़ेगा ना. If we do not allow anything to escape, if I allow all of the water to convert into gas and then this gas is heating up and heating up, then it will increase the pressure so much that the entire cooker will burst. So that is why to regulate pressure, I need that vessel. Area of hole in the lid. If that area is very large, more gases will release and that will decrease pressure very, very fast. If the area is less, it will release less gases, that will decrease pressure slowly. Weight of the lid. If that weight is very heavy, lid is very heavy, lifting up that lid will be much, much more difficult. If that weight is very less, lifting of the lid will be easier. So that weight of the lid and this area of the area of hole in the lid, that actually determines the pressure which is inside this cooker. And that pressure determines that what temperature water is going to boil. That flame temperature only determines that how fast this water will vaporize. That's it. But जो pressure अंदर कितना built है, वो flame temperature decide नहीं कर रहा है. That inbuilt pressure is being decided by the area of the hole and the weight of the lid. So that is why second is not correct. The answer is 1 and 3 only. So this was a very simple concept of thermodynamics where you had to appreciate that pressure cooker is a mostly closed system and the temperature, because क्वेश्चन ये नहीं बोल रहा है कि खाना आपका किन पैरामीटर्स पे डिपेंड करेगा. क्वेश्चन ये है कि टेम्परेचर एट विच द फूड इज कुक्ड विच इसेंशियली इज बॉइलिंग पॉइंट ऑफ वाटर हियर, ये कौन से पैरामीटर पे डिपेंडेंट होगा, ये क्वेश्चन है. एंड ये टेम्परेचर जो है दैट इज डिसाइडेड बाय pressure inside the cooker, and that pressure inside the cooker is decided by that hole in the lid and the weight of the lid. It is not decided by flame temperature. That is why second statement is wrong here. Answer is 1 and 3. C is the correct answer. I'm not saying without temperature. Question is कहाँ question बोल रहा है कि without temperature है. Question ये बोल रहा है कि आपने flame को बढ़ा दिया, temperature बढ़ा दिया, flame को कम कर दिया. ये बस ये करेगा कि आपने कुकर में जो पानी रखा था वो पानी कितना जल्दी वेपराइज हो गया है, राइट. अगर फ्लेम टेम्परेचर ज़्यादा है तो पानी जल्दी. क्वेश्चन इज नॉट आस्किंग हाउ फास्ट और स्लो इट विल बी कुक्ड. देखो अब यहाँ पे कंफ्यूजन क्यों है. वाई सम पीपल थॉट दैट दिस क्वेश्चन यहाँ पे सेकंड ट्रू होना चाहिए. क्वेश्चन ये पूछ ही नहीं रहा है कि कितने जल्दी या कितनी देर से खाना बनेगा. क्वेश्चन ये नहीं पूछ रहा है. क्वेश्चन पूछ रहा है कि कितने टेम्परेचर पे खाना बनेगा. और बस ये है कि अगर मैंने फ्लेम टेम्परेचर को बहुत कम कर दिया तो जो भी मेरा वाटर है उसको वेपोराइज होने में ज़्यादा टाइम लगेगा. बट जो प्रेशर अंदर कितना बिल्ट होगा दैट इज डिसाइडेड बाय हाउ मच स्टीम इज देयर इनसाइड दैट पर्टिकुलर कुकर, एंड हाउ मच स्टीम विल बी देयर दैट इज डिसाइडेड बाय दैट वेट एंड दैट एरिया ऑफ द होल. So flame temperature will not play a role here, right? So question is not asking how fast or how slow food will be cooked. It is more about that at what temperature the food will be cooked. And because of that, answer is 1 and 3. So that is why I said that reading that question carefully is very, very important. This is a very simple question of biology. Which of the above can be cultured in artificial synthetic medium? इसमें बस हमको एक चीज ध्यान रखना है कि जो वायरस है, वायरस is considered as a bridge between living and non-living. Virus is not considered a living organism because it cannot multiply all by itself. Viral cell जो है, it cannot lead to cellular multiplication all by itself. But it is also non-living. It is also not non-living because when it infects some other organism, that other organism can be a bacteria, that other organism can be some other parasite, it can be a plant, it can be an animal, it can be a fungi. But when it infects some other organism, it hijacks their cellular machinery and then it uses the cellular machinery of the host to multiply. And then it multiplies very rapidly, it grows exponentially, right? So in an artificial synthetic medium, you simply cannot culture virus because it is not possible to do that without a host. If you want to replicate virus in a lab setup, then use some bacteria, use some fungi, use some plant, infect them. Take a bacteria, infect them with a virus, and bacteria को multiply करो. Bacteria multiply होगा, virus multiply होगा. But ये again हमको living organism चाहिए to do that. We cannot do that in some non-living artificial synthetic medium. So that is why third is not correct. Answer is 1 and 2 only. But bacteria culture and fungi culture ये बहुत popular चीज़ है. Bacterial multiplication, fungal multiplication, इसके करने के बहुत तरीके हैं. Some people, I should tell you this. Yeah, I should tell you this. That some people interpreted that artificial synthetic medium, including that, let's say in a petri dish I have bacteria and I have infected that bacteria with a virus and then I'm multiplying bacteria, hence I'm multiplying virus, then will it be considered artificial synthetic medium, right? So some people did interpret this, and I often feel the people who actually did interpret this is that they had medical science as background. Right? They knew more about the topic, right? So I often feel like that sometimes this over analysis can also be a problem, right? So but nonetheless ये थोड़ा सा, I will not say that ये बहुत ज़्यादा controversial statement है, थोड़ा सा controversial है. But artificial synthetic medium जब भी हम ये word use करते हैं, then essentially we talk about that ideal condition of light and nutrition and everything कि bacteria को हमको multiply करना है, plant buds को multiply करना है, तो एक ideal condition हम provide करते हैं जहाँ पे चीज़ों का multiplication बहुत high rate पे हो. That is the meaning of artificial synthetic medium. Virus कोई भी ideal condition आप provide कर दो, if there is no living host, it is simply not going to multiply. So hence third statement is not correct. This is another fantastic question. Also very simple question. Water can dissolve more substances than any other liquid because it is dipolar in nature. Water is one of the most amazing molecules perhaps in the known universe. It is the simplest but the most amazing molecule. Let me tell you why. Water is made of hydrogen and oxygen. Hydrogen goes into liquid at minus 253 degrees Celsius. Oxygen goes into liquid at about minus 193 degrees Celsius. And both of them come together, make water, which becomes liquid at 0 degrees Celsius. Right? Above 0 degrees Celsius, it is liquid. Below 0 degrees Celsius, it is solid. That in itself is quite remarkable. But hydrogen, oxygen are बहुत simple molecule है. बहुत सारी चीजें नहीं है, बहुत simple molecule है. It is a covalent bond. It is a covalent bond. But covalent bond में क्या होता है कि electron is shared between two things. If there are two molecules, then electron is shared among two molecules. The problem here is that अगर ये दो molecule या दो atom अगर O और O रहता, O2 रहता, तो ये ऑक्सीजन एटम दूसरा ऑक्सीजन एटम दोनों का जो इलेक्ट्रॉन एफिनिटी है, that it wants to pull electron towards it to gain stability, that is same, right? So there will not be any charge distortion in O2 or N2. But in H2O, so I have O and I have H. So in H2O, this O has more tendency to attract electron toward. We use a parameter called electron affinity. So oxygen has this higher electron affinity compared to hydrogen. So even though this electron is being shared among oxygen and hydrogen, this oxygen and hydrogen, this electron cloud is more towards oxygen, and because of that, there is a very small negative charge here, often shown with delta minus, and there is this very small positive charge here shown here with delta plus, which makes water bipolar. But the amazing part here is that because it is bipolar, now think of this oxygen molecule which has this less electron towards it, and think of some other water molecule, HOH. So now they make a hydrogen bond, a very simple weak bond, but they make a hydrogen bond. And if I put something else which is also polar, such as let's say salt, salt सबसे simple example है. Anything which is not homonuclear atom, such as O2 or N2, there will be some polarity. So if I put something, any polar substance, then this negative oxygen will bond to the positive part, and that positive hydrogen will bond to the negative part, and that object will dissolve. So hence the answer is actually very simple. It is dipolar in nature. And since many of the materials which we use they also have some polarity, they are going to dissolve very, very easily in water. So correct answer is A here. Water has more amazing properties. I have only talked about few of them, but it has more amazing properties. This I would say is a little bit difficult question. Like you had to know about few things, and only then you can answer this question. The question is, with reference to street lighting, how do sodium lamps differ from LED lamps? Sodium lamps produce light in 360 degree, but it is not so in the case of LED lamp. अब ये इसका क्या मीनिंग है, जब तक अगर आपको क्लियर नहीं है तो फिर ये क्वेश्चन आप नहीं कर पाओगे. एक टिपिकल जो लाइट बल्ब हम यूज करते हैं, दैट लाइट बल्ब इल्यूमिनेट्स लाइट इन ऑल डायरेक्शन, सो इट कवर्स दैट 360 डिग्री. एलईडी का देखो सबसे बड़ा फायदा क्या होता है कि जैसे मान लो अगर मुझे इस रूम में लाइट चाहिए, एलईडी लाइट है, तो हमको लाइट यहाँ पे चाहिए, हमको पूरे रूम में हम वहाँ पे कुछ और एलईडी लगा देंगे. ऐसा तो है नहीं कि हमको पूरे जगह लाइट चाहिए, हमको क्लियरली ऊपर नहीं चाहिए, साइड में नहीं चाहिए, साइड में ज़्यादा लाइट की ज़रूरत नहीं है. सो एलईडी विच इज़ लाइक दिस वेरी स्मॉल रेड ब्लू ग्रीन टुगेदर, illuminating together in the same intensity, producing white light. हम इसको इस तरीके से डिजाइन कर सकते हैं, all of this very small red, blue, green, that they can direct their light in a specific direction. And I can make LED which can produce light only in 90 degree. I can make LED which can produce light only in 180 degree. So now imagine what is happening here. ये light bulb जो है, मान लो 10 watt का था. It was illuminating entire room, but I can produce the same light if I only want 90 degree by 10 by 4 light, and if it is 180 degree I can do the same thing with just by 10 by 2 wattage. So LED becomes more energy efficient. LED consumes much less energy compared to any other type of bulb which we use. Right? पहले जो bulb हम use करते थे तो और भी खराब था, वो तो literally was because of heat is producing into light, it was loss of lot of energy. But even other bulbs like LCD or sodium light bulb, these things they still are not that energy efficient. LED is. So ये सही है. That sodium lamp which produces this yellow light, it produces in 360 degree. LED can be directed 90 degree, 180 degree, 120 degree, and we can arrange LED to do that. At street lights, sodium lamps have longer lifespan than LED lamps. अब इसको eliminate करना आसान था. This was not a difficult statement. Like the moment you read about benefit of LED, the first benefit you read is high energy efficiency, and the second benefit you read is longer lifespan. So while all other bulb will become wasted very soon, LED bulb often will have twice, thrice, 4 times, 5 times lifespan. So that is another benefit of LED compared to all other bulbs including sodium lamp. So second is not at all true. Eliminating second was correct, right? So if I know second to be wrong, then I can get this A and C to be correct. I know that either A is correct or C is correct, which also tells me that third statement is correct, right? but I still have to know that first statement. So that is why I thought that this is a little bit difficult question, that you should know that LED can be directed in a way that जो पूरा light है एक 90 degree या 180 degree में हम produce कर सकते हैं. So and that is why that makes this question little bit difficult. Third statement is, even though this statement is also difficult, but my answer is not dependent upon this statement. That spectrum of visible light from sodium lamp is almost monochromatic. Sodium light, अब ये थोड़ा सा यहाँ पे they went into technicality of things. Sodium lamp produces two wavelengths. And the two wavelengths, both of them are separated by only about like few angstrom, I guess 5 or 10 angstrom. I also have forgotten. But since that wavelength difference is so less, I can assume it to be monochromatic. So, and by the way, they are saying that it is almost monochromatic. It is also not saying that it is exactly monochromatic, but it produces two wavelength. Monochromatic का मतलब होता है only one wavelength. And almost monochromatic का मतलब है that if there are wavelengths, they are not very far away from each other. They are very close to each other. Sodium produces this yellow color wavelength. Both of them are very close to each other. LED lamp offers significant color advantage. That is very simple. Red, blue, green. I can have either red, either blue or green. Illuminate all three of them in same light, same intensity. I have white. But change their intensity, I can produce all the possible colors which we know. These are three primary colors, and with help of these three primary colors, I can produce all other colors. So third part is, this part is true, that LED lamps offer significant color advantage in street lighting. So first is true, this third is true, second is not true, answer here is C, right? But knowing that first was important here, only then you could have get the answer correct. This is earlier topic which I already have discussed. Which one of the following is a reason why astronomical distances are measured in light years? That is a direct consequence of special theory of relativity. That speed of light remains constant in all frame of reference. So since speed of light does not change, if I use this distance, that in 1 year how much distance light travels, I call that distance light year. Light year is a measurement of distance. So correct answer here is D. Speed of light is always same. Why some people got confused? Distances among stellar bodies do not change. ये तो clearly wrong है. ये तो बिल्कुल सही हो ही नहीं सकता. Gravity of stellar bodies does not change. First of all, that is wrong, and second of all, it doesn't even matter. How does that explain velocity of light? But in any case, it is also not correct, because sun का mass बहुत heavy है, but sun gains and lose mass, mostly loses mass. Light always travels in a straight line. अब यहाँ पे देखो, ये वैसे तो correct है, except affected by gravity, but even then it is not an explanation of that why we are using light year as a unit of distance for astronomical distances. That even though most of the time it is correct, that's also not a problem. Why some people thought that D should also not? I remember talking to many students and many of them had marked C as the answer. And why they thought D to be wrong? Because they thought that light तो bend करता है, और light का जो speed है वो तो water में कम हो जाता है, light का speed glass में कम हो जाता है. तो galaxies के बीच में water नहीं है, galaxies के बीच में glass नहीं है. So I can easily assume that the distance, astronomical distances do not have denser medium, right? And even in air, by the way, air is not vacuum. Air जो है atmosphere है, it is not exactly vacuum. But even within air, velocity of light is almost 3 lakh km per second, right? So I can easily assume that velocity of light, by the way, it is always same in all frame of reference. It only decreases in a medium. But for astronomical distances, we do not have to worry about that. So that is why correct answer is D here, right? So speed of light is always same, a consequence of Einstein's special theory of relativity. That explains the answer to this question. Universe is really huge. Sunlight takes 8.3 light minutes. Proxima Centauri, the nearest star, is 4.3 light years away. The nearest galaxy, Andromeda galaxy, which you can see from your naked eyes. That is the farthest object which you can see from naked eyes. Andromeda galaxy देखने के लिए आपको लद्दाख वगैरह जाना पड़ेगा. दिल्ली से नहीं दिखेगा. But if you go to places where sky is very clear, one part of this sky will be dense with star, and then there will be some empty part of this sky, and then you will see a light, dispersed light. It will not be a star, but you will see like not exactly one star, but a spread light source somewhere in the sky you can see. That actually is not one star, but that is Andromeda galaxy, which is a bigger galaxy than Milky Way galaxy. But Andromeda galaxy is 2.5 million light year away. Right. Anyways, this is about light years. This was a question asked this year. ये 2024 का question है. This is one of the questions which I consider, even though it is a question of science and tech, it is very factual, and only those who have very good knowledge of biology will be able to answer. But it's a good thing then that you simply have to skip such questions. इस question को attempt करने का कोई meaning भी नहीं है. Right? And ऐसा भी नहीं है कि जैसे मान लो आपने बचपन में कभी पढ़ा था कि कोई तो ऑक्साइड ऑफ नाइट्रोजन था, बट उससे भी आपका आंसर नहीं होगा. ऑल ऑक्साइड्स ऑफ नाइट्रोजन आर गिवन. NO, NO2, N2O, N2O5. All of the molecules are oxides of nitrogen. So correct answer is NO here, nitric oxide. That NO, even though is a pollutant if consumed in very high amount, if you inhale NO in very high amount is a pollutant. Your body does produce that in very small amount, which essentially dilates your blood vessels. It allows more blood flow to occur, and it reduces the stress on our arteries and veins. So it's a good thing that your body can produce this very small amount of NO. So, but this is a very factual and a core question of biology, like understanding of human body. And only with students with like proper background in the topic will be able to answer the question, right? So answer is A here, and I will repeat that in such questions, do not try to be smart. Like जैसे for example, अगर आप smart बनने की कोशिश करोगे, तो आप नाइट्रोजन पेंटाऑक्साइड मारोगे, बिकॉज आपने NO, NO2 पढ़ रखा है कि ये तो पॉल्यूटेंट है, N2 आपने पढ़ रखा है कि ये तो ग्रीन हाउस गैस है, लाफिंग गैस भी है, सो देन यू विल से दैट N2O5 ठीक लग रहा है, राइट? सो यू विल मार्क दैट एज द करेक्ट आंसर, बट दैट विल बी रॉन्ग ऑफ कोर्स. चलो, लेट्स टेक अ ब्रेक हियर. After that we will discuss this next set of topics from space technology. Then we will discuss biotechnology, health and ICT. इस तरीके से हम progress करेंगे.
Does the vast syllabus of general studies for the UPSC prelims overwhelm you to initiate your preparation for the civil services examination? Is your apprehension and self-doubt coming in the way of your success in joining the civil services? Comprehend your preparation for UPSC Prelims 2025 with the fast-track course targeting general studies with innovative curriculum, revision and mentorship. Starting from 19th November at 1 p.m, the course offers coverage of UPSC GS Prelims subjects, dedicated mentorship support and guidance for performance maximization, access to PT 365 classes for current affairs preparation, sectional mini tests for regular assessment and performance, personalized student portal to access study material, access to live and online classes. Enroll today and make prelims your stepping stone to proceed to the UPSC mains.
In which of the following activities are Indian remote sensing satellites used? Assessment of crop productivity, locating groundwater resources, mineral exploration, telecommunication, traffic studies. And then there was a very similar question in 2019 for the measurement estimation of which of the following are satellites images remote sensing data used. Chlorophyll content in vegetation, greenhouse gas emissions from rice paddies, land surface temperature of a specific location. Remote sensing satellites are very powerful tool. If you have an atlas, then when you look at your physical map and map about resources, then those maps were prepared with help of remote sensing satellite data, or map about forest cover, forest resources. So except the political map, in fact, even in political map, remote sensing data can be helpful. But except that political map, all other maps which you have in your atlas, lot of input in preparing that map must have been taken by remote sensing satellite data. So remote sensing satellites are essentially equipped with lot of optical instruments, and these optical instruments take images of Earth's surface. But you should not think of them as a very simple camera. हमारा जो मोबाइल फोन का कैमरा है, that uses these three primary colors, red, blue and green. So there are remote sensing satellites which do very powerful optical imaging, that they are also taking image in red, blue and green, of course with much wider area and much higher resolution. But imaging is not only optical imaging. There is something called thermal imaging, that as objects heat up, they radiate infrared radiation. And then there are satellite sensors which are capable of capturing that infrared, which will tell you the heat map of the world. So for example, this imaging will be very helpful if you have to, let's say, understand volcanic eruption, or let's say if you have to understand impact of global warming, that sea surface temperature is increasing, or let's say you have to understand urban heat island effect. Urban heat island effect पढ़ा आपने environment में, that urban areas का जो temperature है ज़्यादा है compared to the surrounding. So in thermal imaging, urban areas will appear to be brighter. So it's no longer a theory. We can actually confirm this, that the urban area's average temperature is more compared to the surrounding with help of remote sensing satellite. We can do radar imaging. Radar imaging is in fact using radio waves, not even visible light or infrared, but using radio waves. Now the thing with radio waves is that they are not naturally occurring. So you have to first produce them and then you measure the reflection. Jesse, think of this like how a bat navigates or how a dolphin navigates. पढ़ा आपने bats and dolphins के बारे में? What is the technique they use? Echolocation. That echolocation essentially is nothing but a sonar technique. What a bat does or what a dolphin does is that they produce sound waves, ultrasonic sound which our ears are not capable of listening. And as that sound gets reflected from the objects in front of them, how much sound was reflected, how much was absorbed, how much time it took for that sound to be reflected, based on that, they have a very good awareness about their surrounding. Just say, I have a very good awareness about my surrounding with help of light. Just say, I can see that you guys are sitting in the front, you are at the back. So light allows me to see all of you. But it not just allows me to see all of you, it also allows me to distinguish all of you. It allows you to understand me, to understand the color of clothes you are wearing. It allows me to understand the distance of this class, people who are sitting at the back, people who are sitting at the front. Light carries information with it, but even sound carries information with it. Dolphins use sound waves to see the world. How dolphins see the world, we will never know. Right? But we can use this in a technology. That is what ultrasonic technique is used in pregnancy, to know about unborn babies. पढ़ा होगा आपने, ये तो सब सुना होगा, that we use ultrasound, right? So X-ray imaging अगर हम करेंगे, X-ray is dangerous radiation that can damage tissues of unborn baby. So we use sound imaging. We use ultrasonic technique to know about the movement of unborn baby inside the tummy of mother. So when we do radar imaging, we use a similar principle, but rather than using sound, we use radio waves. And the best part about radio waves is that radio waves, so जो radar sensors होंगे, so let's say if there is a satellite equipped with radar sensor, radio wave का full form is radio detection and ranging. Sonar का जो full form है वो है sound detection and ranging. Radar का full form is radio detection and ranging. So satellites which are equipped with radar sensors, they will first produce their own radio wave. And how much time it took for that radio wave to be reflected by various surfaces, that will allow them to create a very good map about the objects and about the surface of Earth. And the benefit of using radio wave is that radio wave can cross through many things which visible light or infrared cannot, particularly cloud. So cloud, rainfall, इन चीज़ों से radio wave को कोई ज़्यादा फर्क नहीं पड़ता. I will not say कोई फर्क नहीं पड़ता, but these things affect visible light or infrared much more. Particularly visible light is affected a lot. If there is, let's say, dense cloud, but radio wave can cross through that very, very easily. So radar imaging allows you to see things even when optical imaging is not allowing you to do that. So there are many remote sensing technique. And the best part of light is that light only not just tells you the distance or the color or the physical features, it also tells you the chemical properties. That only by analyzing the pattern of light, just for example, we see that leaves are green. Why are leaves green? We have learned that. That is the color which leaves are reflecting the most. But why are they reflecting that color the most? Because for photosynthesis, green is not useful. For photosynthesis, blue is much, much more helpful. Yellow is much, much more helpful. So the chlorophyll molecules, they absorb that blue and that yellow a lot, but they do not absorb green, and green gets reflected. The point I'm trying to make here is that what type of light will be absorbed and what type of light will be reflected and what type of light will be emitted and what type of light will be scattered, all of that depends upon the atomic and molecular composition. Carrot looks orange because of carotenoid molecule. Carotenoid reflects orange color the most. The point I'm trying to make here is that light not only carries the information about distance and color and size and shape, it also includes the information about the atoms and molecules it has come in contact with. And there is a branch in science called spectroscopy, which does precisely this, that it analyzes detailed pattern of light, and based on that, it tries to understand the atomic and molecular structure of things. So now you can appreciate that here answer will be D. That remote sensing satellite data, it can measure the chlorophyll content. That green color जहाँ से सबसे ज़्यादा है, सबसे ज़्यादा वहाँ पे chlorophyll है of a specific location. In fact, this is the data which is used to measure the green cover. Many things are done, but one of that is chlorophyll content. But greenhouse gas emissions are again nothing but molecules. These are carbon dioxide, methane, N2O, nitrous oxide. So from a specific location, again, we can do that also. And third, we can always do temperature. We can always measure with help of thermal imaging. Will be very helpful in measuring the temperature of Earth's surface. So answer is 1, 2, and 3. The point you need to remember is that light carries a lot of information. You simply have to know how to decipher that information. So some information is very obvious for us to appreciate. That the distance, I know that this chair is here, that chair is far away. Why do I know that? Because the light reflected from this chair reaches to my eyes much faster compared to that light, and my brain knows how to distinguish that, right? But spectroscopic devices can also answer questions like why I'm wearing a pink shirt. So why this color is pink or why some other color is green, right? And we can actually know about the atoms and molecules, about the fabric we are wearing, what type of chemicals were used to dye this shirt versus what type of chemicals were used to dye some other shirt. We can determine that with spectroscopic analysis. So remote sensing techniques, spectroscopy is very powerful technique. Answer here is D. But in that earlier question, remote sensing data allows you to measure moisture in soil, pest attack of a crop. Overall for soil monitoring we use this. आप एक अगर आपको देखना है तो एक इसरो एक पोर्टल मेंटेन करती है, वेदास पोर्टल, एंड इसरो एक और पोर्टल मेंटेन करती है, भुवन पोर्टल. Just go and explore these two portals maintained by ISRO and you'll get the idea about remote sensing information I'm talking about. So first is correct. We can also locate groundwater resources, not directly. जहाँ पे भी ground water बहुत ज़्यादा होगा, वहाँ पे जो surface characteristic है, जो soil characteristic है, that will be different. So remote sensing data will provide you this indirect information about the probability of aquifers. And that will allow us now to do, let's say, on-ground exploration, that the extent of natural aquifer. तो aquifer mapping के लिए, ground water resources को locate करने के लिए, again we can use remote sensing data. And this we already do. जो आपके map में जो resources वाला map है, lot of that is because of remote sensing data. This we do not do because remember, there is a separate type of satellites called communication satellites, which are used for telecommunication purposes such as radio and television. That is not the purpose of remote sensing data. If I know 1, 2, and 3 to be correct, 4 to be incorrect, then I know my answer is A here. The problem is this option, that can I use remote sensing data for traffic studies? The answer is yes, I can. Are we using Indian remote sensing satellite for that? 2015 तक तो नहीं कर रहे थे, ये 2015 का क्वेश्चन है. हो सकता है कि पिछले 10 साल में कुछ लोगों ने, कुछ IITs ने, हो सकता है जो ट्रैफिक स्टडीज करते हैं, they might have asked government of India to share the data of remote sensing, and they might be using this for traffic studies. So it is possible, but are we using it? Is ISRO using it? ISRO is not using it for traffic studies, that I know. I have explored ISRO's website in a lot of detail. Nowhere I found traffic studies. Maybe some other institution has received data from ISRO and they might be doing it, but I do not know about it. In any case, my answer is not dependent upon this option. Answer is 1, 2, and 3. A is the correct answer. Sorry? What correction will be done? Toll collection, GPS. For toll collection, we will be using GPS. There is a question on GPS also. Let me come to that question. The term Goldilocks zone, often seen in the news, is in the context of, there is a very famous children's story where there is a little girl called Goldilocks who goes to a bear family. And in the bear family, there are 3 members. There is Dada bear, Mama bear, and baby bear. And the Goldilocks, this little girl, goes and sees that there is a bed which is very hard, so does not sit there. There is a sofa which is very soft, does not sit there, but finds a cushion which is of optimum hardness, and she sits on that. She finds that there is some milk which is very hot, does not drink that. A milk which is very cold, does not drink that. But milk which is lukewarm and drinks that. And she does like many things, and bears come and they see that everything is disarranged. It's a very famous children's story. I recently got this opportunity to read that story to my son, who is 4 years old right now. So I know this story for very long, and then people use this word Goldilocks in many cases. So Goldilocks is used in taxation, that if your tax rate is very high, if government is collecting very high tax rate, then people will start doing tax evasion, right? That is another problem. आप पूरा invest करो money laundering में, वो अलग problem है. If you collect very less tax, then you do not have enough revenue to do public work. So there is this zone of taxation which is considered this Goldilocks zone of taxation. In astronomy, it means that if planet is very close to the star it is revolving, then this planet will be so hot that life will not be possible. And if a planet is very far away from the star it is revolving, then the planet will be so cold that life will not be possible. But there is a zone where the temperature will be optimum and life is possible. For example, in case of solar system, that zone is Earth, clearly, and that zone is Mars also. So even Mars is in Goldilocks zone, that there can be possibility of life on Mars. Moon clearly is also in Goldilocks zone, right? So यहाँ पे जो question है, that the term Goldilocks zone often seen in the news is in the context of जो zone है, that is used for Earth-like planets in outer space. Earth-like planet का मतलब है habitable planets. That finding habitable planets which are neither very close nor very far away from the star, and the correct answer here is C. बाकी सारे गलत हैं. Like अगर limits of habitable zone above the surface of Earth, this is not correct. ये similar सा कुछ लग रहा है habitability, but this is not correct. It is not about Earth. It is about, with respect to star, how far away the planet is. If it is very far away, it will be very cold. If it is very closer, it will be very hot. Astrosat, such type of themes will not be asked. Exposat will be an important topic, let's say for 2025 prelims. X-ray polarimeter satellite, which was launched by ISRO. So in 2015, ISRO launched Astrosat, and UPSC asked a question on this topic in 2016. This was the first astronomical observatory launched by ISRO. The goal here was to know more about astronomical phenomena such as distant stars and galaxies, and stars in many stages of evolution. But look at the statement it is asking. It is not asking about those things, what it aims to do. Other than US and Russia, India is the only country to have launched a similar observatory into space. This is it's not a factual statement. Prima facie, it may look like a factual statement, but it is not. You think of some other space agencies apart from India and Russia, and you try to think that space agencies which have more capability than India, and there are many. China clearly is much more capable. European Space Agency is very much capable. Japan, Canada, there are many countries. Their space program is more advanced. They have more fund, more resources. Not because of the lack of talent. Not because so ISRO is not doing enough. Not because of lack of talent. They clearly are doing many things, but simply that other countries are investing much more fund, right? And first statement because of that is not correct. That such type of observatory only US and Russia. And second statement also looks like a factual statement. 2000 kg. Who remembers mass of spacecraft, right? But the second option should have been eliminated. Is in an orbit of 1650 kilometer above surface of Earth. So had you read that this mission has been launched into low Earth orbit, and yes, theoretically low Earth orbit goes up to 2000 kilometer. Low Earth orbit का जो definition है वो है 200 से 2000 kilometer. So theoretically low Earth orbit is up to 2000 kilometer, but practically the most useful orbits exist between about 400 to 800 kilometer. You will hardly find such type of space missions which are beyond 1000 kilometer. So that gave you a hint that even second statement is not correct. अब देखो प्रॉब्लम क्या होता है कि यूपीएससी एक बार ऐसा क्वेश्चन पूछेगी और लोग रटना शुरू कर देंगे कि जो सैटेलाइट है उसका कितना मास है, जो इसका ऑर्बिट क्या है. डू नॉट डू दैट. व्हाई डू यू हैव टू डू दैट? ये क्वेश्चन ऐसे लग रहा है कि फैक्चुअल है, बट नहीं है इतना फैक्चुअल. दिस कुड हैव बीन एलिमिनेटेड एंड यू कुड हैव गेट द राइट आंसर. एंड इन एनी केस, इवन इफ यू कुड नॉट, even if let's say it is a very factual question, do you really think you are capable of remembering such facts? You are not. So first of all, thankfully UPSC does not do that. They do ask factual question, but इतने घटिया facts नहीं पूछेंगे वो, right? तो इस मामले में UPSC काफी better examination है. जो UPSC Civil Services Prelims है काफी better examination है. They are not asking, and by the way, this was 1500 kg and this was 650 kilometer. तो यूपीएससी कभी ये नहीं पूछेगी कि 650 के बजाय 700 पूछ लिया उन्होंने और 675 पूछ लिया. दे विल नेवर डू दैट, राइट? इफ दे आर ट्राइंग टू मेक इट रॉन्ग, दे विल गिव यू एम्पल ऑफ लीवे. सो आंसर हियर इज डी, नीदर वन नॉट टू. एमओएम का भी देख लो. एमओएम का ऑब्जेक्टिव नहीं पूछा है. मार्स ऑर्बिटर मिशन नो लॉन्गर इंपॉर्टेंट. वी हैव लॉस्ट द कॉन्टैक्ट विथ मार्स ऑर्बिटर मिशन. एट दैट पॉइंट ऑफ टाइम ऑफ कोर्स इट वॉज सो मच इन न्यूज. यूपीएससी मेड अ क्वेश्चन ऑन इट. Mangalyaan launched by ISRO is also called Mars Orbiter mission, which essentially mean that it orbited around Mars. There was no lander, there was no rover, it was only a orbiter. So first is true. Made India the second country to have a spacecraft orbit the Mars after USA. This also does not seem logical. Again, same logic which I applied in AstroSat, that you have China, you have European Space Agency, you have Russia. So second statement is also not correct. Third statement made India the only country to be successful in making its spacecraft orbit the Mars in its very first attempt. Now that part is correct. So this was the record that India did it successfully in its very first attempt. All other countries before India, their first or even two experiments had failed. India was the first country to do that. One more thing which was very much in news, that the per kilometer cost I remember was about 5 rupees, and that was less than auto cost. So that was also like prominently covered, that the total mission is very cost effective. तो यहाँ पे जो आंसर है 1 and 3 है, C is the correct answer. So again same thing, prima facie looks like a factual question, but it is not at all a factual question. We can eliminate options and get the right answer. This is a factual question. Greased lighting, ये तब आया था. This was a electric, this sort of hybrid plane NASA is testing, even though it has not abandoned. Some challenges have occurred. It has not abandoned exactly. So this was an electric plane which can be powered with help of lithium-ion battery rather than using some sort of fuel, right? Rather than using some liquid fuel, they are powering this plane with help of battery. So this was in news at that point of time, and this one line question was asked. but ये factual question है. Like this does not give you, the name does not give you a lot of, and also this is not something done by some Indian agency. So at that point of time, if you remembered this, if you read this in current affairs, very well, but you do not have to remember this at all, just because it was asked by UPSC in 2016. ये तब का current affairs है. इस टाइप का करंट अफेयर्स जो पिछले साल 1.5 साल में है आ सकता है. जैसे आई विल लर्न अबाउट यूरोपा क्लिपर मिशन, अभी आया था परसों न्यूज़ में. सो आई लर्न अबाउट यूरोपा मिशन. यूरोपा इज वन ऑफ द मून ऑफ जुपिटर, known for water and ice above this water. The best candidate to have life in solar system after Earth is this place called Europa. Jupiter cannot have life because Jupiter is a gaseous planet, cannot have life. But Europa is solid and Europa has a very large water surface covered by ice, and there is a possibility that there is some life there, right? So anyways, यहाँ पे answer is A. Then there was a question about PSLV and GSLV. This is again a very standard question. Like इसका कोई current affairs से लेना देना है नहीं. अगर ये current affairs में हो नहीं हो फर्क नहीं पड़ता. You can expect questions like this about rockets of ISRO. PSLV का full form जो है Polar Satellite Launch Vehicle है. Polar orbits are very useful for this remote sensing satellites, and remote sensing satellites are used for, one of the application is resource monitoring. तो पहला statement यही है, useful for Earth resource monitoring, that makes sense. GSLV, G here signifies geosynchronous. Geosynchronous orbits are generally used for communication satellites. That is the statement. Are designed mainly to launch communication satellites. So first statement, no problem. Second statement is very beautifully designed statement, that satellites launched by PSLV appear to remain permanently fixed in the same position in the sky as viewed from a particular location on Earth. There is only one orbit which has this description. There is only one orbit which seemed to be fixed with respect to a point on Earth, and that point must be on equator, and this orbit is called geostationary orbit. That a satellite, when it revolves about 35,786 kilometer, you can think of it like this. So you can think of this tip of the pen as my satellite and this point on equator, and as Earth rotates, satellite revolves with same angular velocity. So it will seem like that the satellite is fixed with respect to this point on equator. But for geostationary orbit, we generally use GSLV. Can we use PSLV? Yes, if my payload is not very heavy, I can use it. But it is not asking about exception. It is asking that as a rule, generally, if I am using PSLV, then where will I launch? Generally, that will be some low Earth orbit, some polar orbit. If I am using GSLV, where it will be launched, that will be some geosynchronous, geostationary orbit. So that is why second statement is not correct. That satellites launched by PSLV appear to remain permanently fixed, which means geostationary orbit. And PSLV, as the name suggests, was designed for polar orbits. It was, of course, it can be used for LEO. Third is not correct. GSLV is a 4-stage launch vehicle. First and third solid, second and fourth liquid. That is description of PSLV. So GSLV Mark III hai. That is the most powerful rocket of ISRO. So this is PSLV. This is the first stage, carried solid fuel. Second stage, third stage, fourth stage, so solid, liquid, solid, liquid. This is GSLV Mark II, solid, liquid, cryogenic. This is LVM3, which was earlier called GSLV Mark III. Again, solid, ये जो side में दिख रहा है, solid, liquid, and cryogenic. So that third statement is a description of PSLV. It is not a description of GSLV. You eliminate third option. You know first to be correct, but you also know second to be not correct. Second is not correct because PSLV launches generally satellites into polar orbit. Answer here is one only. If you have questions here, you can ask questions, or in previous questions also. Sorry?
Etc. also.
Do we have to remember ASLV, SLV? That older rockets which ISRO had, not at all. Just say right now I will try to remember about existing rockets, including SSLV, small satellite launch vehicle, right? But I will not go and remember about the first rocket SLV or the second rocket ASLV. वो हमको करने की जरूरत नहीं है. In which areas? Yes, you have a question.
So in the beginning of the session, you told that Einstein told like that at time and space are not too independent from each other. Next, you told about singularity, that it has infinite density. Sir, and in that case also, sir, will gravity will be very high. So if we combine both points, what can we tell about time and space in the case of singularity?
That part I actually did answer. As per our existing laws, we cannot say anything about singularity because we simply do not understand singularity. We are using this word singularity for the center of black hole, where our mathematics is telling us that there is some infinite density. In physics, infinite does not suit. In maths, infinity is fine. I can do integration from minus infinity to plus infinity, that is fine. In physics, we do not take infinite literally. Saying that a point has infinite, you think of infinite का meaning क्या है? So the Einstein's theory, general theory of relativity and singularity, it can only tell us one thing, that my laws of physics break down here. What are laws of physics at the singularity? We simply do not know. And that's totally fine. In scientific method, we have to accept this, that this remains a mystery and we simply do not know. That is totally fine to accept. So I will make a simple statement. It only tells us that our laws of physics break down at singularity.
Okay.
अच्छा, आप लोग माइक का वेट कर रहे थे क्या क्वेश्चन पूछने के लिए? अभी तक तो क्वेश्चन नहीं आ रहा था ज़्यादा, बड़े सारे क्वेश्चन आ. दैट्स अ गुड थिंग बाय द वे, but good that you are waiting for mic. Anyways, go ahead.
Sir, as before the break, you said that light travels in like a straight light, but we know, and this is also established that light had dual nature, like particle nature as well as the
Wave nature.
Yeah. So, and with the theory of wave nature, light travels in, like light shows the interference. Like how light travels in a straight, as you said, like.
But I do not. Why are you connecting that with? Why are you connecting that with wave or particle nature? Like, what is the relevance of that part in your question? Your question it's simply that why is light traveling in a straight line? Is that your question? Okay.
Yeah.
Objects travel in a straight line. You can, so if I can explain that at many levels, the simplest level I can explain this is using Newton's laws of motion. In Newton's laws of motion, the first law, which tells us that objects want to maintain their natural state of motion unless there is an external force upon it. So I can simply say that the effect of external force on light is negligible, and because of that, neither their velocity will change. Velocity change means they're accelerating, so light is not accelerating, nor will they change the direction, because even if I change my direction, I have to apply some force. Any force on light will be negligible. So I can say that light is going to maintain constant velocity. That is the starting point. But this is not actually the correct answer. But I can explain the straight line velocity with help of that also. The second part of explanation will be the nature of space-time itself. अब ये थोड़ा ज़्यादा complex है. So what we perceive as light traveling in a straight line, by the way, I also should also be very clear that we can also perceive light as bending. But that light bends only when the gravitational effect is very, very strong. I already have told you that this very powerful gravity can bend the space-time curvature. And because of that light, we can perceive this light to be bending. So light bends also. But if space-time curvature is straight, then light does travel in a straight line, right? And इसको हम appreciate इस तरीके से, अगर हम light के perspective से अगर हम देखें तो हम appreciate कर सकते हैं that light actually does not experience time. जो photon है, photon के लिए time का कोई meaning नहीं है. जैसे मान लो कि अब इसको प्रूफ किया जा सकता है मैथमेटिकली. Photon does not experience time. A light coming from sun takes 8.3 minutes for it to reach. फोटॉन के लिए जो भी स्पेस इंटरवल है और जो टाइम इंटरवल है वो हमेशा जीरो है. हमारे लिए वो स्पेस 150 मिलियन किलोमीटर है, एंड बिकॉज ऑफ दैट वी सी दैट 8.3 मिनट. फोटॉन के लिए वो डिस्टेंस जीरो है और वो टाइम भी जीरो है. So for a photon, the time is that it emerges and it vanishes. That's it. So when I say length contraction and time dilation, that happens simultaneously. Let's say if a proton is traveling with very high speed, let's say c by 3, very high speed. So if a proton experiences, let's say, 5 minutes, then that 5 minutes in that proton, it's same as how we experience 5 minutes. The only thing is that for this proton, how we perceive distance will be different. So again, the things are a little bit complicated here. We have to use a lot of mathematics. But using that light as my frame of reference, also I can explain that why it is a straight line, right? Using Newton's law also we can explain why is it a straight line. To change the direction of the light, we need some sort of mechanism. And that mechanism can be gravitational force, but apart from that, there is no mechanism. And because of that, light travels in a straight line. You can think of it like this. Any other question? People who want to speak in mic? It's totally fine. I'm only joking. You can please do that. Please ask questions. Anyways, there is a question that in which of the following areas can GPS technology be used? So remember, GPS is a navigational satellite. It provides you the precise location where you are on Earth, your latitude, longitude, as well as altitude. So not just on Earth, even in atmosphere. If you are at some height, you can determine your altitude also. You need data from minimum 4 satellites. So think of this as a GPS electronics device. There is a satellite. This electronic device should be capable of receiving data from 4 independent GPS satellites. And when it receives minimum from 4 satellites, it can determine its precise location. How does it happen? GPS satellites are equipped with a very powerful clock which is called atomic clock. An atomic clock can measure time with very, very high accuracy. So GPS signal, whenever it is transmitted, there is a time stamp that when that signal was transmitted. How much time it took for that signal to reach here? That time can be measured with help of atomic clocks. Multiply that time with speed of light, because the signal is essentially radio signal traveling with speed of light. And one GPS satellite knows the distance. But if I know the distance only from one point, then I can be anywhere on a sphere. आप ऐसे समझ लो that I often do this exercise in classes, that think of that on this board there is a treasure and you have to know the location of this treasure without, you can ask a question about the reference about this treasure, but you cannot ask me where the treasure is located. And then if I ask a puzzle from you now, that in how many minimum number of questions you'll know the location of the treasure, the answer will be 3. That, let's say, on this board somewhere there is a treasure. You cannot ask me the location of the treasure, but you can choose a random point. And with help of this random point, you ask that from this random point, how far this treasure is located. And it tell you that it is located, let's say 10 meters away. Then you take that random point which you have chosen and you draw a 10-meter circle around it. And then you know that this treasure is somewhere on this circle, isn't it? You choose a second random point in the same manner. And you ask that from the second random point, how far this treasure is. And it tell you that it is 15 meters away. You take that second random point and now you make a 15-meter circle around it. And you do the same thing with third random point. I tell you 20 meters. You take that 20-meter circle around it. And where these 3 circles intersect, you know that this is where treasure is located. But in case of 3D, if I ask the same question in this room, that there is a treasure in this room, and again you follow the same logic, you will choose a random point and you'll ask that where the treasure is. And then I tell you that let's say it is 15 meters away, but then you have to draw a sphere. You have to draw a spherical surface of 15 meters and you know that this treasure is somewhere on the sphere. You choose the second point, you draw another sphere. Two spheres, when they intersect, they will make a circle. And then third sphere will make this 2 point, and the fourth sphere will make this one precise point. So if there is a GPS receiver, such as my mobile phone, that all of our mobile phones are equipped with a GPS electronic receiver. So if this GPS receiver receives data from these 4 satellites independently, then it can determine its precise latitude, longitude, and altitude. And the second part which we should appreciate, that since GPS satellites are equipped with such powerful clock, which measures times with very high accuracy, that it also provides us timing services. And we have to synchronize time across many devices. We use GPS satellite. The best example here is banking operations. That in banking operations, how, by the way, iska answer D hai. Let me explain all of that. In mobile phone operation, that is very simple. All of our mobile phones are equipped with GPS receiver. That's very simple. First is, we know that first is correct. How it has applications in banking operation? In many ways. A vehicle which carries cash to an ATM, that vehicle has to be tracked. That is a security feature. If you are using some mobile banking app or even UPI, it will not work if you have not enabled your location. देखा आपने कोई भी मोबाइल बैंकिंग ऐप पूछता है ना आपसे कि अपना लोकेशन इनेबल करके रखो. दैट इज अ सिक्योरिटी फीचर, दैट वेयर एग्जैक्टली दैट ट्रांजैक्शन इज हैपनिंग. So GPS is being used as a security feature. So that is another application. But even synchronizing all the branches, जैसे मान लो that as per RBI guideline, all the bank branches have to close the today's settlement of all the cash which was deposited and all the loan they dispersed by 3:30. Then no matter a bank branch which is in Tamil Nadu or which is in Jammu and Kashmir, they have to be synchronized together. So for such synchronization, again, we use GPS satellite. So there are many ways how GPS satellite has applications in banking operation. And the same is also true for control of power grids. So power grids control in multiple ways again. Even in installing power grid, जैसे कहीं पे कोई power plant है, some power plant where we are burning coal, that produces energy. We are converting that energy into electrical energy, and with help of these transformers and poles, we have light in this room. This infrastructure is called power grid. But in power grid, first in its installation itself, where to install power grids to optimize our power transmission, we can use GPS data. But even to ensure that different transformers are being synchronized together, many transformers are being synchronized together so that we can deliver maximum output of power, we use that timing services of GPS. So in controlling power grid, again, GPS has many applications. Answer is 1, 2, and 3 here. Coming to your question earlier, that we have, अभी आजकल हमारे जो बड़े अच्छे मिनिस्टर हैं, काफ़ी सारा उन पे ऐसे मीम बन रहा है आजकल, राइट? अभी मैं आज ही मीम देख रहा था कि गडकरी जी बात कर रहे हैं वैष्णो साहब से, और गडकरी जी वैष्णो साहब को बोल रहे हैं कि देखो ट्रेन अगर रोड पे आ गई एक्सीडेंट से तो टोल देना पड़ेगा. सिंपल. सो जो टोल वाला जो है काफ़ी मीम बन रहा है उन पे. तो एनीवेज, हाईवे कंस्ट्रक्शन इज हैपनिंग एट रियली गुड रेट, गुड हाईवेज. टोल कलेक्शन जो है वो पहले क्या होता था कि यू हैव टोल बूथ, कैश दो, वेट करो एक सब पूरे चेंज का, तब तक लंबी लाइन लग गई है. सो हैड लाइक ह्यूज कंजेशन. We replaced that with RFID, radio frequency identification technology. There is a FASTag. That FASTag has encoded information about your bank account. There is a FASTag reader device at the toll booth. It reads the encoded information, money gets automatically deducted. The traffic congestion has reduced, but has not been eliminated. Without a doubt, on the toll booth, traffic congestion has reduced. इसमें कोई doubt नहीं है. Which also reduces your fuel consumption, reduces your carbon footprint. There are so many benefits, but it has not been eliminated. Also, your toll is based on if you have crossed the toll or not based on how much kilometer you have traveled. So you could have gone to some place, you simply had to go somewhere and come back, you pay some toll, and some other person traveled for 150 kilometer, paid the same toll, if it only there was only one toll. So to eliminate that, what NHAI is proposing right now, that the new vehicles and hopefully the older vehicles also, they will be equipped with a GPS device. And rather than toll booths and person, there will be some cameras here. These cameras are going to capture the images of your vehicle. आपका जो नंबर प्लेट है वो फिर थोड़ा चेंज होगा, उसको चेंज करना पड़ेगा, that उस नंबर को रिकॉग्नाइज करना आसान हो. And then this data will be sent to some centralized portal of maintained by NHAI, and they are going to match that data with how much kilometer of distance you have traveled with help of GPS, and then money will be deducted automatically. So the goal here is that in next few years we will completely eliminate the necessity of toll booths. Let's see how it happens. So GPS has multiple sets of application, including even in toll booth toll collection. So यहाँ पे जो आंसर है वो D है. 1, 2 and 3, all three of them are correct here.
A strong hold over current affairs is your way to succeed in the UPSC Civil Services examination. Brace yourself and get detailed coverage of relevant news both nationally and internationally. With the monthly current affairs revision program starting from 26th October at 5 p.m. Enroll today and elevate your current affairs knowledge with comprehensive coverage of current affairs compiled through relevant sources such as the Hindu Indian Express, Economic Times, PIB Yojana and others. Expert support and personalized mentoring. Comprehensive assessment through MCQs and mains-oriented questions.
There was another question on navigational satellite in the same year about our NAVIC program. But NAVIC was earlier called Indian Regional Navigational Satellite System. So this is a regional navigational satellite system, right? And यहाँ पे जैसे third statement देखो NAVIC रहता तो फिर भी confusion होता. Third statement क्या है, that India will have its own satellite navigation system with full global coverage. नाम में regional लिख रखा है, तो full global coverage क्यों होगा? So you can always eliminate third. By the way, if you go to ISRO website, then they mention that since the 7 satellites, 4 of them are in geosynchronous, 3 of them are in geostationary, and as benefit of geosynchronous geostationary is that satellites revolve in the same time as Earth rotates. So the 7 satellites which are above India, as Earth rotates and satellites revolve, they will always be above India. So if you are in India and if you have a NAVIC enabled electronic device, then with help of NAVIC also you can know your location, latitude, longitude, altitude. And not just in India, if you go to ISRO website, they mention 1500 kilometer beyond India's border. So even if you are 1500 kilometer beyond India's border, you will be able to know the locational information. And 3 of them are in geostationary, 4 of them are in geosynchronous. So if you look at the question, India will have its own satellite navigation system with full global coverage. That is wrong. It covers India and about 5500 square kilometer beyond border. So it is 1500 kilometer, convert that into square will come out to be like million square kilometer. So that clearly is wrong. And first, it has 3 satellites in geostationary and 4 satellites in geosynchronous. That part is correct. Answer is 1 only. You can expect question on NAVIC even in future. ये ऐसा है टॉपिक जो हमेशा न्यूज़ में रहेगा, और न्यूज़ में हो या ना हो, we should know about NAVIC program of ISRO. So now we are calling it NAVIC, Navigation with Indian Constellation. And maybe in future, this will be made into a global program. Right? I was watching an interview few months ago of Dr. Somnath, and he did talk about that maybe 10 years down the line, from regional, with launching more and more number of satellites, we will make it global. There was a question on solar storms. Solar storms को लेके जो understanding है, वो काफ़ी improve हुआ है अभी. And Aditya L1 mission is also, it has been launched. So वो भी news में था. So in that context, UPSC asked a question on solar storm. देखो solar storm होता क्या है? अच्छा, by the way, UPSC ने भी ये mistake कर रखा है that they have used solar storm and solar flare together, which is not correct, right? Solar storm is a word which includes many things. It includes solar flare, it includes something called coronal mass ejection, and it also includes something called solar wind. But all of these 3 things themselves are separate. you find from certain places on the sun surface called sunspots, where temperature is less, magnetic field however is very powerful, that from time to time you have this sudden release of hot plasma. So from photosphere, the release of radiation, electromagnetic radiation, which often is X-ray, ultraviolet, visible light. Some can be infrared also, but most of that will be ultraviolet light and X-ray. To scale, this is Earth and this is a solar flare. So one solar flare essentially can be thought of as like thousands of atomic bombs exploding together. It's a very powerful, energetic event. But an associated phenomena with solar flare is coronal mass ejection. That from the outermost layer of sun, which we call corona, you have billions of tons of plasma expelled in the solar system. Why they are not same thing? Because both of them may occur together, but both of them describe two separate things. Solar flare is radiation, electromagnetic radiation, which you can immediately see in 8.3 minutes. Coronal mass ejection is charged and magnetized particles traveling with very high speed, but they are going to take about 12, 15, 20 hours before they can reach to Earth. I often use the example of a cannon ball. Think of the medieval time में जो cannon use करते थे, तोप जो use करते थे. So आप gunpowder use कर रहे हो. Imagine if this gunpowder was visible to us. तो gunpowder जो जलेगा, वो आपको बहुत पहले दिख जाएगा. So you can think of that as flare. But जो cannon release होगा, that will be released in a specific direction. You can think of that as coronal mass ejection. There is something called solar wind. Solar wind is a more frequent phenomena. That is also charged particles like electrons, protons. But the concentration and density of charged particles is much less. In coronal mass ejection, it is much, much more high. And these three things together is called solar storm. And when solar storm reaches to Earth, there is an amazing thing. Earth in itself is a very powerful magnet. Earth का जो magnetic field है, that essentially emerges from this outer core. Outer core is liquid, and outer core में बहुत सारे charged particles हैं, and lot of radioactivity is happening. And whenever charged particles move, they release powerful magnetic field. So I can draw this. That this is Earth's magnetic field. So when solar particles do reach to Earth, the Earth's magnetic field repel a lot of these particles, but some particles can enter from polar areas. And they can cause aurora. So solar wind causes this shimmering of light which we see during night sky at North Pole and South Pole. We call it aurora, which was asked by UPSC in men's examination this year. And this disruption in Earth's magnetic field due to solar storm is called geomagnetic storm. So if a solar storm is not very powerful, then you can witness this beautiful color of light in North Pole and South Pole, which is called aurora. But if it is powerful, then depending upon how powerful, many things can happen. जैसे intense auroras could occur over much of the Earth. This is possible. That auroras will no longer only be visible at North Pole and South Pole. You can witness them also from Ladakh, for example. इस साल एक news था that in January or February people witnessed aurora from Ladakh. And हम tropical region में. Something which happens in polar areas is being witnessed in tropical region. So fourth is correct. If it is even more powerful, then it can disrupt the communication satellites and GPS satellites, because a sudden concentration of electrons and protons can disrupt the electronics of your satellites. Satellite के अंदर का जो electronic system है, that can be damaged because of charged particle. So this is true. GPS and navigation systems could fail, and that can also affect the shortwave radio communication of the aircraft flying over polar regions could be interrupted. So that is also correct. If it is very, very powerful, जो सबसे powerful जो solar storm होगा, Now we are talking about these charged particles entering in the Earth's lower atmosphere, causing a surge of electricity in our grids, and our grids are not designed for surge of electricity. So that could cause damage in many part of the Earth, and many part of the Earth can be suffering from a blackout. But this is a very rare event. इसको होने के लिए जो class of solar storm है वो बहुत ही powerful होना चाहिए first. And solar storm देखो sun पे कहीं पे भी हो सकता है, and sun is really huge. तो बड़ा ही unfortunate हो, Earth is very small compared to sun. So Earth is revolving around sun. Somewhere solar storm has occurred, and somehow Earth is in direct line of sight of this attack. Think of that cannonball directly hitting the Earth. So that probability is very, very low, but it is not zero. But when that happens, it is going to cause damage to power grid. So that is also true. It can also affect orbits of satellites. Remember, orbits of satellites can be affected if there is any type of drag. जैसे मान लो, why do we not launch satellites into air? Can we attain an orbit in air? Yes, we can. The problem is that in air, there is a lot of air, and air opposes motion. So there will be air drag. And air drag force जो है, that is proportional to your velocity. जितना ज़्यादा velocity होगा, उतना ज़्यादा air drag होगा. Which essentially mean that आपका velocity कम होते चले जाएगा. और velocity अगर कम होगा, आपका orbit धीरे धीरे नीचे होते चले जाएगा और आप गिर जाओगे. So we cannot have orbit in the atmosphere. We have to go outside atmosphere where atmospheric particles are almost absent. There is no drag force. Once you launch something, it can find a stable orbit there. But if there is a sudden surge of particles, electrons and protons, then even though surge of particle can affect orbit a little bit. Not a lot, but a little bit this orbit can be affected. So even that is true. But ये जो statement है, tsunamis could occur at equatorial region. That is not at all true. Tsunamis occur because of very powerful earthquake, right? And earthquake is not triggered by solar storm. Earthquake is triggered by plate tectonics. We have learned that in geography classes. And we also haven't found any causality that solar storm is triggering a forest fire on Earth. So even if you can eliminate 2, you have your answer. The answer is 1, 3, 4, 6, and 7. C is the correct answer. But you should know that even this is possible. Orbits of satellites could be disturbed. Even this is possible. Power grids could be damaged. But for that to occur, we need to have very, very powerful solar storm. There was a question, there has been like questions from astronomy in 2023, then also in 2024. Cepheids, nebula, pulsars. And the question is how many of the pairs are correctly matched? अब यहाँ पे थोड़ा सा scope of elimination है. जो pulsars हैं बहुत ही common word है. Pulsars are essentially neutron stars which are rotating on their axis. And as they rotate, they release pulses of energy. And they release that pulses of energy at very periodic interval, and hence the word pulsar. So this is the statement, neutron stars that are formed when massive stars run out of fuel and collapse. This is correct. Nebula is a place where the density of stellar dust and gaseous particle is very high, and that stellar dust and gas is essentially raw material for the formation of a new star. So in nebula regions, new stars are formed. If I know this, then I know that this cannot be true, and this also cannot be true. Nebula is stars which brighten and dim periodically. Not at all. Nebula is a place in universe known for stellar dust and gas where stars take birth. So nebula is this, giant clouds of dust and gas in space. And Cepheid is this. So even if I did not know Cepheids, even then I know that first is not correct, second is not correct, third is correct, answer is only 1. So there is some scope of elimination even in questions like this. What are Cepheids, by the way? Cepheids are these very giant stars. They are so giant that there is a tug of war between gravitational force and nuclear fusion. So they expand and contract. Their size is not very fixed. So when they expand, they become dimmer. When they contract, they become brighter. And because of that, their intensity changes. And by the way, that change in intensity is very helpful for astronomers because they use Cepheid's to know the distance of this is actually used to measure the distances at very large scale. So Cepheid stars are very useful for astronomers. All of these topics are in news quite often because of James Webb Space Telescope. I have given many references, just 2 references here, but there are many more references in last few years you can find about these things. So this is a picture of like a simple cycle how stars take birth from a nebula region. If it is a star like sun, this is going to take, ये सबसे बड़ा टाइम पीरियड होगा, बिलियन साल, 7-8 बिलियन साल तक ये वाला, सॉरी एवरेज स्टार ये होगा, but it finally will end into a white dwarf star. That will be the fate of sun. But if it is a very heavy star, it will become supernova. That is called that collapse which was given, and it can lead to a neutron star or a black hole. There was a question this year also on a similar theme, that giant stars live much longer than dwarf stars. That is statement. This is assertion reason. And compared to dwarf stars, giant stars have a greater rate of nuclear reaction. By the way, even if you did not know about first statement to be wrong, by the way, first statement is wrong actually, you should have known that second statement clearly is not an explanation of statement 1. If rate of nuclear fusion is more, then it should ideally mean that they should live for lesser duration. So अगर ये statement रहता that giant stars have shorter life than dwarf stars, and ये statement 2 रहता जो इस जैसे है, तो आंसर A होता. ये सही नहीं है. Statement 1 is not wrong. So this is you often may think that if a star is very large or very heavy compared to, let's say, sun, then it should live for longer. The exact opposite is the case. If a star is let's say 1000 times bigger than sun, and there are stars like this, while sun can live for, जो sun का जो mature stage है 8 billion साल का है, such stars will have life in 1 billion year, and there are stars which can also have life of only 10 million years. Compared to 8 billion, 10 million is very small. Hence I use the word only. That should be clear. So in this question, that statement 1 is wrong. Statement 2 is actually correct. That giant stars have a greater rate of nuclear reaction, that is fusion reaction. And if statement 1 is wrong, my answer is fixed. D is the correct answer. Statement 1 is incorrect, but statement 2 is correct. One more question let's discuss and let's complete this class. This is again another factual question. Which one of the following countries has its own satellite navigation system? If you do not know this, then you should not attempt this, because all 4 of them are developed countries. तो ये कोई logic भी नहीं लगा सकते that maybe some developing nation should not have, but all 4 of them are developed nations. The answer here is Japan. That so there are very few navigational satellite programs in the world. GPS is the most famous one, which belongs to America. GLONASS belongs to Russia. Galileo belongs to Europe. BIDO belongs to China. NAVIC belongs to India. But NAVIC is regional, and जो अभी मैंने 4 नाम लिए, GPS, GLONASS, Galileo, BIDO, these are global. And apart from these 5 names, there is one more. That's it. These are the only 6 navigational satellite program. And that 6th one is called Quasi-Zenith Satellite System, QZSS. And that belongs to Japan, but ये independent system नहीं है. जैसे जो नाविक है वो independent है. नाविक का GPS से कोई लेना देना नहीं है. नाविक का GLONASS से कोई लेना देना नहीं है. But QZSS satellites, these are only 4 satellites, Quasi 4. So these are 4 satellites launched by Japan, which improves the accuracy of GPS in Asia Pacific region. So if you are in Asia Pacific, which includes East Asia, Southeast Asia, Australia, if you are in this region, then you will have better accuracy. It improves the accuracy of GPS. So it is not an independent regional navigational satellite system. It improves the accuracy of GPS satellite. But in this question, nonetheless, the answer is D, that out of these 4 nations, only Japan has its own navigational satellite system. And other nations are US, Russia, Europe in general. So not one nation, but a region, entire region. Europe, and then you have China, of course, and finally you have India, right? So these are the questions of space technology. If you have any questions till now, you can ask questions. Sorry, can you repeat your question? First line. क्या? Can you, which distance between two?
Two car.
Two car.
Yes. जीपीएस कैसे उसको मेजर करती है, किस तरह से?
ओके, तो सबसे पहले तो जो टोल कलेक्शन में हम, इट इज़ नॉट अबाउट डिस्टेंस बिटवीन टू कार्स, बट हम वो तो आराम से बहुत मेजर कर सकते हैं वैसे. तो वो मेजर करना तो बहुत आसान है. इफ़ आई नो दी लैटिट्यूड लॉन्गिट्यूड ऑफ वन कार एंड इफ आई नो द लैटिट्यूड लॉन्गिट्यूड ऑफ अनदर कार, देन उस डिस्टेंस को मेजर करना बहुत आसान है. बट अ बिगर प्रॉब्लम हियर इज दैट हाउ मच डिस्टेंस द कार इन इटसेल्फ हैज ट्रैवल्ड. तो वो जीपीएस कोऑर्डिनेट कैसे इसका चेंज हो रहा है, that can be done with help of powerful computers. We have really good computers which can continuously analyze as the GPS coordinate is telling us that this car is changing its coordinate, and we can analyze that and we can determine how much distance the car has traveled. Okay. Any other question? So tomorrow we will discuss rest of the question. Hopefully we'll be able to complete remaining questions. We'll start our discussion with biotechnology and health. Then we will talk about ICT and other topics also. Okay, so I'll see you guys tomorrow.